Hello there, and welcome to Science for Sleep, where curiosity slows down, explanations take their time, and big ideas are allowed to stretch out gently until they no longer feel heavy. Wherever you are listening from tonight, whether the lights are already low or the world outside is still quietly busy, I'm glad you're here. This is a place for wondering without rushing and learning without needing to stay wide awake. Tonight, I want to invite you on a journey that begins very close to home and then keeps going, far past the places most of us picture when we think about space. Not a fast journey, and not a dramatic one, but a steady, patient drift outward, guided by a small machine that has been travelling for longer than many people listening have been alive. A machine that keeps whispering back to us even now from a place so distant that the word far starts to lose its meaning. Before we go any further, let me ask you something simple and personal. Where are you listening from right now? Are you curled up in bed, resting on a couch, or perhaps listening through headphones while the room around you slowly quiets down? And what time is it for you, in your part of the world at this exact moment? It's fitting to ask, because tonight's story is not just about space, but about time, distance, and how our minds struggle to hold both at once. If you find this gentle exploration calming, interesting, or simply a nice way to unwind, you're always welcome to like the video or subscribe. It helps this small pocket of quiet science reach others who might need it too. There's no rush and no pressure. Just know that you're welcome here. Now let's begin slowly. Imagine receiving a message from something that left Earth before many modern conveniences existed. Before smartphones, before the internet became part of daily life, before GPS quietly told us where we were without us ever thinking about satellites or signals. Imagine that message arriving not seconds or minutes after it was sent, but many hours later, crossing distances so vast that even light itself needs most of a day to make the trip. And imagine that message still coming, steady and patient, from a place where the sun is no longer the bright ruler of the sky, but just one star among countless others. This is not science fiction. This is happening right now. Far beyond the orbit of the outer planets, beyond the neat diagrams most of us saw in school, a spacecraft continues to move outward, carrying instruments, data, and a faint heartbeat of radio signals back toward Earth. Those signals do not shout, they whisper, and yet, in those whispers, they tell us something deeply unsettling and strangely comforting at the same time. They tell us that the solar system is far larger, emptier, and more extended than our intuition ever prepared us for. When most people picture the solar system, the image that comes to mind is often compact and tidy. This sun in the centre, a few planets arranged around it like ornaments on invisible rings, and perhaps a vague sense that space ends not too far beyond the last planet. Even when we know, intellectually, that this picture isn't accurate, it's hard to let go of it. Our brains like manageable scales. They prefer distances that can be compared to road trips, flights, or at most, the size of a country or an ocean. But space does not care what our brains prefer. The spacecraft sending these messages, one of the Voyager probes, was never designed to redefine our sense of scale. At the time of its launch, it had a more practical purpose. It was meant to visit the giant planets, take close-up images, measure their magnetic fields, sample their environments, and then, if everything went well, keep going. What no one could fully feel, even if they understood it mathematically, was just how long that keep going would last, and how much space there was still left after the last planet faded behind it. As Voyager travelled outward, something subtle began to happen. The familiar markers we used to measure distance stopped being useful. Millions of kilometres, then billions, became numbers that technically describe reality, but no longer helped anyone picture it. Even astronomical units, the distance between Earth and the Sun, started stacking up in ways that felt abstract rather than informative. This is where Voyager began to quietly reveal the true scale of the solar system, not through a single dramatic moment, but through patience, through year after year of movement without a rival. through the simple fact that it kept going, long after many expected the solar system to be over. One of the strangest things about deep space is how empty it feels, even when something is happening. Voyager did not pass through a sudden wall or a bright boundary marking the end of the sun's influence. There was no signpost, no sharp edge, no cosmic fence. Instead, the solar system thinned out gradually. The solar wind, that constant stream of charged particles flowing from the sun, grew weaker. The influence of our star became less dominant, more subtle, more easily disturbed by the environment beyond. From Earth, it is tempting to think of the sun as powerful and all-encompassing, a force that defines our entire cosmic neighbourhood, and in many ways, it does. But Voyager showed us that even the sun has limits, and those limits are spread across distances so large that they feel almost gentle rather than dramatic. The solar system does not end. It fades. As Voyager moved farther away, sunlight itself changed character. The warmth we take for granted diminished until it was no longer a meaningful source of energy. Darkness became the default. The spacecraft relied on the slow decay of radioactive material to keep its instruments alive, a tiny internal fire burning quietly while the surrounding space grew colder and quieter. There is something oddly comforting about that image, a small, steady source of power continuing to function in an environment that offers no help at all. Voyager does not hurry. It does not slow down in any way that feels noticeable. It simply continues, carrying with it the accumulated effort of thousands of engineers, scientists and technicians who knew they would never see its final destination, and still it sends its messages home. Each signal takes many hours to arrive. When Voyager transmits data, it does so knowing that Earth will not hear it until long after the spacecraft has moved on. In a sense, we are always listening to Voyager's past. What we receive now describes a place the probe was many hours ago, and by the time we process that information, it is already even farther away. This delay is one of the first ways Voyager forces us to confront scale, not through distance alone, but through time. Cause and effect are stretched. Now becomes fuzzy. The idea of real-time communication, something we're so used to, quietly stops applying. And yet, despite this delay, the connection remains. Voyager is still part of our world, even as it leaves it behind. As the probe continued outward, scientists began to notice changes that hinted at something important. The behaviour of particles around Voyager shifted. The balance between solar material and interstellar material started to change. The environment was no longer dominated by the sun alone. This was not a sudden transition. There was no single moment when Voyager crossed a clean line from inside to outside. Instead, there was a long region where influences overlapped, where the sun's presence weakened and the galaxy's presence grew stronger. That overlapping region is vast, larger than the distance from the sun to any planet, larger than most people ever imagine when they hear the phrase, edge of the solar system. And Voyager drifted through it slowly, methodically, measuring conditions that no spacecraft had ever measured before. What those measurements revealed was unsettling in its simplicity. The solar system is not defined by planets. The planets are just small islands near the centre. The true size of the solar system is defined by how far the sun's influence reaches into space, and that reach extends far beyond Neptune, far beyond Pluto, and far beyond anything we can see with our eyes. This realization forces a quiet mental adjustment. If the solar system is this large, then the space between stars must be larger still, and if the space between stars is that vast, then our everyday sense of position, importance, and proximity begins to soften. Not disappear, but loosen. Voyager does not lecture us about this. It does not explain it in words. It simply keeps going, and in doing so, it asks us to notice how long going can last. There is something deeply human about following this journey. We launched Voyager at a time when optimism about exploration ran high, when the idea of reaching beyond known boundaries felt natural rather than overwhelming. But what Voyager has given us is not just data about space. It has given us a lesson in patience, in scale, in how small steps accumulate into distances that redefine entire concepts. As you lie there listening, it may help to imagine Voyager not as a machine racing through space, but as something drifting calmly outward, like a leaf carried by a very steady current. There is no urgency in its motion, no destination it must reach by a certain time, just forward movement, measured in years and decades rather than minutes or hours. That calm persistence is part of why Voyager's story fits so well here, in a place designed for rest. The probe does not demand attention, it invites it. You can think about it for a moment, then let the thought drift away, knowing it will still be out there, still moving, still quietly expanding the map of where here ends. Long before Voyager became a distant whisper at the edge of the sun's influence, long before it redefined how we picture the solar system, there was a single ordinary day on Earth when everything quietly began. Not with mystery or drama, but with checklists, weather forecasts, coffee cups cooling on desks, and people doing their jobs carefully, one decision at a time. This is often how history actually starts, not with thunder, but with preparation. On that day, humanity did something simple and extraordinary at the same time. We built an object with no return ticket, placed it on top of a powerful rocket, and aimed it away from everything familiar. Then we let go. If you pause for a moment and picture Earth on that day, it helps set the scale of what was happening. The planet was busy being itself. People were going to work, arguing, laughing, worrying about bills, cooking meals, missing trains, and making plans for the weekend. Children were learning things that would later be outdated. Radios played songs that would eventually feel nostalgic. And meanwhile, on a stretch of coastline, a small group of people focused on a machine designed to leave all of that behind. Voyager was never meant to be a hero. It was a tool, a carefully engineered collection of instruments, wiring, shielding, and antennas assembled with the expectation that it would face conditions no human-built object had ever faced before: radiation, cold, emptiness, and time, a lot of time. The decision to send Voyager outward was rooted in a rare alignment of planets, something that happens only once every 176 years or so. The giant planets, Jupiter, Saturn, Uranus, and Neptune, had lined up in such a way that a spacecraft could visit them in sequence, borrowing a little energy from each one's gravity to fling itself onward. This technique, called a gravity assist, allowed a small probe to achieve what would otherwise require impossible amounts of fuel. Even knowing this, the plan was ambitious. The distances involved were already beyond everyday comprehension. Jupiter alone is hundreds of millions of kilometers away. Saturn is much farther still, and beyond them lay planets that, at the time, were barely more than fuzzy disks through telescopes. Voyager was built to survive the journey, but survival did not mean comfort. There would be no repairs, no upgrades, no second chances. Every component had to work not just once, but for years, maybe decades. The engineers knew that eventually something would fail. The only question was how much could be learned before that happened. And yet, woven into the technical goals was something quieter and more human. Voyager carried a message. Not a message in the usual sense of radio transmissions or coded data, but a physical artifact meant for anyone or anything that might one day encounter it. Attached to the side of the spacecraft was a golden record, protected by a cover etched with instructions on how to play it. On that record were sounds and images from Earth, music, greetings in dozens of languages, the sound of wind, thunder, laughter, a baby crying, a heartbeat. It is easy to dismiss this as symbolic or sentimental, but it represented something profound. We were not just sending a probe to gather information. We were sending a small piece of ourselves into the dark with no expectation of reply. Think about that for a moment. Voyager was designed to leave the solar system entirely, to travel through interstellar space for millions, even billions of years. Long after Earth itself may have changed beyond recognition, Voyager could still be drifting, carrying a record of who we were when we decided to reach outward. This was not done because anyone seriously expected it to be found. The odds are unimaginably small. Space is vast beyond anything we instinctively grasp. But the act itself mattered. It was a statement. We exist. We wondered. We reached. The launch itself was not silent. Rockets are loud, violent things. They shake the ground, fill the air with fire and pressure, and remind everyone nearby that escaping Earth's gravity is not a gentle affair. Voyager did not ease its way into space. It was forced upward, riding controlled explosions, shaking and rattling as it broke free from the planet that built it. Then, suddenly, the violence ended. Once the engines shut down and Voyager settled into its trajectory, the spacecraft entered a very different kind of journey. No more roaring thrust, no dramatic acceleration, just quiet motion, governed by gravity and momentum moving steadily away from the sun. At first, the distances grew quickly in human terms. Voyager passed the moon in hours. It passed Mars's orbit in days. Earth became a pale dot almost immediately, indistinguishable from countless other points of light. Communication delays grew from seconds to minutes, then longer. Still, everything felt close enough to manage. Engineers could send commands and expect responses within a reasonable time. Instruments were turned on and tested. Data flowed back. The solar system still felt like a place we understood. That feeling did not last. As Voyager continued outward, something subtle began to change in the way people talked about it. Timelines stretched. Milestones became measured in years instead of days. The probe would reach Jupiter in 2 years, Saturn a couple more after that. Uranus and Neptune would follow, but only after nearly a decade. This required a shift in mindset. People who worked on Voyager knew they were committing to a long relationship with a machine that would outlast many of their careers. Some would retire before the mission ended. Some would never see its final data return. And still, they continued. There is something quietly remarkable about that kind of commitment. To work on something knowing that its greatest discoveries might occur long after you've moved on, to trust that others will care enough to keep listening. As Voyager approached Jupiter, it sent back images that changed how we saw the giant planet forever. Storms larger than Earth, moons with active volcanoes, a world far more dynamic than anyone expected. Each discovery reinforced the idea that sending Voyager had been worth it. But even as these discoveries unfolded, Voyager was already doing something else. It was building momentum, not just physical speed, but narrative momentum. With every success, it became easier to justify letting it keep going. After Saturn, the original mission goals were technically complete. Voyager had done what it was sent to do. It had visited the giant planets and transformed them from distant points of light into complex worlds. At that point, many missions would have ended. Voyager did not. Instead, the decision was made to let it continue, to repurpose it as an interstellar probe, to see how far it could go and what it might encounter along the way. This decision, simple as it sounds, is what ultimately led to Voyager revealing the true scale of the solar system. Because up until that moment, the solar system was still mostly defined by planets, by orbits, by things that could be named and neatly categorized. Letting Voyager go meant accepting that the most interesting part of the journey might lie beyond all of that. As Voyager moved farther from the sun, sunlight weakened. Solar panels would not work here. Voyager relied instead on radioisotope thermoelectric generators, devices that convert the heat from radioactive decay into electricity. These generators provided a slow, steady supply of power, decreasing slightly each year. This imposed a kind of countdown. Instruments would eventually have to be turned off to conserve energy, choices would be made about what to keep alive and what to let go. Voyager would not fail all at once. It would fade, and still the signals would continue for as long as possible. Each transmission was a small act of defiance against distance, a radio signal spreading outward at the speed of light, thinning as it expanded until it reached Earth's antennas hours later, barely distinguishable from background noise. Listening to Voyager required patience and precision. Earth's receivers had to be pointed with incredible accuracy. The signal was weak, unimaginably so. And yet, with careful attention, it could be heard. There is something deeply fitting about that. A faint voice, travelling across billions of kilometres, carrying information about places no human has ever been, and probably never will be. A reminder that exploration does not always involve footsteps or flags. Sometimes it involves waiting, listening, and being willing to accept how small your presence really is. The day we launched Voyager, we did not yet know how empty the space beyond the planets truly was. We understood it mathematically, but not emotionally. Numbers alone cannot prepare you for years of travel without arrival, for distances that stretch patience as much as fuel. Voyager would teach us that lesson slowly. As it moved outward, the gaps between landmarks grew larger. The time between meaningful events lengthened, and gradually the solar system began to feel less like a collection of destinations and more like a vast continuous environment. This is an important shift. When we think in terms of destinations, we imagine endpoints, arrivals, finishing lines. But Voyager's journey revealed something else. The solar system is not a place you cross and then leave. It is a region that thins out, gradually giving way to something else. That realization did not come all at once. It emerged from years of steady data, from careful measurements of particles, fields, and radiation, from noticing that the sun's influence did not stop where the planets ended. And all of that began on the day we decided to throw a message into the dark. Not a message demanding attention, not a declaration of dominance, just a quiet introduction. Here we are. This is what we sounded like. This is what we valued enough to record. As Voyager continued outward, carrying that message with it, it became a kind of mirror. By watching it leave, we learned something about ourselves, about our patience, our curiosity, our willingness to invest in futures we may never personally witness. You might notice as you rest and listen that this story does not feel rushed. That is intentional. Voyager's journey does not reward hurry. It rewards persistence, the kind of persistence that continues even when progress feels almost invisible. In the distance between one signal and the next, between one year and another, Voyager kept moving, quietly, steadily, without needing applause or urgency. And in doing so, it prepared us for the next realization, one that would challenge some of our most comfortable assumptions about how space is arranged. Because once Voyager left the familiar neighborhood of planets behind, once the markers we relied on disappeared, it became impossible to ignore how misleading our mental maps had been. The solar system was not compact. It was vast, and we were only just beginning to feel how vast. That understanding did not arrive as a sudden revelation, but as a gradual stretching of perspective, one that would continue as Voyager pressed on, carrying its message farther and farther, while we stayed behind, learning how to listen across distances. At some point after the last close encounter with a planet, something subtle began to shift in the story Voyager was telling us. There was no announcement, no celebratory marker, no moment when engineers gathered around a screen and said, "This is it." Instead, the change revealed itself gradually, almost politely, as the familiar features of the solar system stopped appearing one by one. Up until then, space had still felt organized, even distant, even large. There were planets to aim for, names to say, orbits to calculate. There was a sense of progression, like moving from one neighborhood to the next, each with its own character. But once Voyager passed the outermost giant planets, that structure quietly dissolved. Imagine for a moment what it feels like to leave a place you know well. At first, the streets still look familiar. The buildings thin out, but you recognize the signs. Then the landmarks become fewer. You drive longer without seeing anything that tells you where you are. Eventually you realize that you're no longer going somewhere. You're simply moving away. That is what happened to Voyager. After Neptune faded behind it, the solar system stopped behaving like a collection of destinations and started behaving like a vast, continuous environment. The planets were no longer guides. The sun was still present, still influential, but its dominance was less obvious than it had been closer in. Space did not end. It opened. From Earth, this phase of the journey is easy to misunderstand. Textbook diagrams often show the planets neatly spaced, with the solar system ending shortly after the last orbit. Even when we add labels like Kuiper Belt or Oort Cloud, they tend to feel like footnotes rather than defining features. Voyager taught us that this intuition is deeply misleading. The distance between planets is already enormous, but the distance beyond them is larger still, and more importantly, emptier. Not empty in the sense of nothingness, but empty of the kinds of objects our minds use to stay oriented. There are no large bodies passing close by, no dramatic flybys, no sense of arrival. This emptiness is not a failure of the mission. It is the message. As Voyager moved outward, it continued to communicate, but the nature of what it reported began to change. Instead of images of swirling clouds or ring systems, the data became quieter. Measurements of particle densities, magnetic field strengths, subtle variations in radiation, information that does not immediately spark the imagination, but slowly builds a picture of where the sun's influence weakens. One of the first things to notice was how sunlight itself behaved. Even far from the sun, sunlight does not vanish. It fades. Its intensity drops according to a simple rule, spreading thinner and thinner as distance increases. By the time Voyager reached the outer regions beyond the planets, sunlight was so weak that it no longer played a meaningful role in powering or warming the spacecraft. This is one of the reasons Voyager relied on internal power sources rather than solar panels. Out here, the sun is no longer a dependable companion. It is present, but distant, like a voice heard across a very large room. That fading presence matters because it helps define what leaving really means. Voyager did not cross a border where the solar system suddenly stopped working. It entered a region where the sun's influence became more subtle, more easily shaped by forces beyond. The familiar neighbourhood of planets is governed primarily by gravity and motion that feels predictable. Orbits follow paths we can calculate with confidence. The sun is unquestionably in charge. Beyond that region, other influences begin to matter more. The solar wind, a constant flow of charged particles streaming outward from the sun, still surrounded Voyager. This wind carries the sun's magnetic field with it, inflating a vast bubble around the solar system. Inside that bubble, conditions are shaped mainly by our star. Outside it, the galaxy asserts itself more strongly. But this bubble is enormous, much larger than the orbit of any planet, and Voyager would spend years moving through its outer reaches before anything clearly changed. During this time, communication delays continued to grow. Commands sent from Earth took longer to arrive, responses took longer to come back. Real-time interaction became impossible. Instead, engineers planned days or weeks ahead, sending sequences of instructions and then waiting patiently for confirmation that Voyager had followed them. This way of working requires trust. Trust in the spacecraft, trust in the models, trust that small decisions made far away will still make sense when they finally take effect. It also reinforces the reality of distance in a way that no number ever could. When you must wait nearly a full day to hear whether something worked, distance becomes part of your thinking. It shapes your expectations. it slows you down. As Voyager left the familiar neighbourhood, it also left behind the comforting illusion that space is busy. Near Earth, space feels crowded with satellites, signals and activity. Even near the planets, there are moons, rings and interactions. Beyond them, there is space on a different scale. Out here, events unfold slowly. Changes are measured over months and years. Nothing rushes. Nothing demands immediate attention. This slowness can feel unsettling if you expect constant progress, but it can also feel calming, especially when you allow yourself to match its pace. Voyager's instruments continue to sample the environment, recording the density and energy of particles it encountered. These measurements revealed that the region beyond the planets is not uniform. It has structure, subtle currents, boundaries that are not fixed but shift over time as the sun's activity rises and falls. This is another way Voyager reshaped our understanding. The solar system is not static, it breathes. The solar wind strengthens and weakens in cycles tied to the sun's behaviour. The boundary between solar influence and interstellar space moves inward and outward over years and decades. Leaving the familiar neighbourhood, then, does not mean leaving something stable behind. It means entering a region where change is slow, but constant. One of the most striking realizations during this phase is how small the planets become in retrospect. They dominate our attention because they are where things happen, where surfaces exist, where gravity shapes dramatic features. But in terms of space, they occupy a tiny fraction of the solar system's volume. If you could somehow compress the solar system into a form you could hold, the planets would be like dust motes near the centre. Everything else would be space-shaped by invisible forces, stretching far beyond what feels reasonable. Voyager moved through this space without ceremony. No fanfare marked the moment when Neptune's influence became negligible. No one could point to a specific day and say, "Now we are truly beyond." The solar system does not offer such clarity. Instead, there was a growing sense of separation. Earth became less immediate, the sun less dominant. The idea of home stretched into something more abstract. This is where Voyager's journey becomes less about exploration in the traditional sense and more about perspective. The spacecraft was no longer discovering new worlds, it was discovering scale, and scale, once truly felt, has a way of changing how everything else looks. From this distance, the inner solar system feels tightly packed. The journeys that once took years now seem almost short. The vastness beyond the planets reframes everything that came before. It also reframes our own position. Earth, which feels so large and complex from the inside, becomes one small participant in a much larger structure. Not insignificant, but not central in the way our daily experience suggests. Voyager does not make this point directly. It simply continues outward, carrying its instruments and its message, letting the distance accumulate. As the probe moved farther from the sun, the solar wind began to show signs of slowing. Its pressure weakened. Interactions with the surrounding interstellar medium became more noticeable. Voyager was approaching a region where the sun's outward push would eventually be balanced by the pressure of space between the stars. This region is vast. Crossing it would take years, and Voyager would do so at the same steady pace it had maintained since launch, without acceleration, without rest. There is something quietly reassuring about that consistency. Voyager does not react emotionally to leaving the familiar neighbourhood. It does not hesitate or look back. It simply follows the path set for it long ago. For those listening now, resting and letting the story unfold, this part of the journey offers an invitation to slow down, to notice how much of our sense of importance comes from proximity, from being near things we recognise and understand. When those things fall away, what remains is not emptiness, but context. Leaving the familiar neighbourhood did not make Voyager lost. It made Voyager free from the need for destinations. Its purpose shifted from reaching places to revealing how much space lies between them. And as it continued outward, the the idea of an edge began to feel less like a wall and more like a gradient, something you move through gradually without noticing the exact moment it happens. Before Voyager ever slipped into the quieter, emptier reaches beyond the planets, there was a long stretch of travel that felt purposeful, almost busy by comparison. The path outward first led toward the giants, the enormous outer worlds that hold most of the solar system's planetary mass. Reaching them was not a short hop. It required patience measured in years, not weeks, and during that time the spacecraft experienced something that is easy to forget when we look back at the mission as a single continuous arc. It had to cross a great deal of space just to reach the first destination. When Voyager left Earth, it did not head straight toward Jupiter like a car driving down a clear road. Instead, it entered a carefully calculated trajectory shaped by gravity, timing, and opportunity. Earth's gravity released it. The rocket's upper stage gave it a final push. Then the sun took over, bending Voyager's path into a long outward curve. From our perspective on Earth, Jupiter feels like part of the same celestial family. We see it in the night sky. We give it a familiar name. But in terms of distance, Jupiter is far beyond anything human beings had ever physically visited before. The gap between Mars and Jupiter alone contains hundreds of millions of kilometers. Even traveling at speeds that would outpace any aircraft ever built, Voyager needed nearly 2 years to arrive. 2 years is an interesting length of time, long enough for jobs to change, for governments to shift, for new technologies to appear. While Voyager crossed the space between Earth and Jupiter, life on Earth continued at its usual restless pace. The probe, meanwhile, moved steadily, unbothered by headlines or seasons. This crossing itself began to hint at scale. The inner solar system, where the rocky planets orbit, is relatively compact compared to what lies beyond. Once Voyager passed Mars's orbit and entered the asteroid belt region, it was no longer travelling between crowded neighbours. It was traversing space that, despite its dramatic name, is mostly empty. Popular imagination once pictured the asteroid belt as a dense field of tumbling rocks that a spacecraft would need to dodge carefully. In reality, the objects are separated by vast distances. Voyager passed through without incident. There were no close calls, no cinematic evasions, just more space. That theme would repeat again and again. Our intuitions, shaped by diagrams that compress distances for convenience, would prove unreliable. As Jupiter grew brighter in Voyager's instruments, anticipation built on Earth. This would be the first close look at the largest planet in the solar system, from a spacecraft equipped with cameras and sensors far more advanced than those used before. Jupiter is not just large. It is massive enough that its gravity influences everything around it. Its magnetic field is immense. Its system of moons is complex. Approaching Jupiter was like approaching a small solar system within the solar system. The gravity assist maneuver that awaited Voyager was both elegant and powerful. By flying close to Jupiter, the spacecraft could steal a tiny fraction of the planet's orbital momentum. Jupiter would lose an imperceptible amount of speed in its path around the Sun. Voyager would gain a tremendous boost, slingshotting outward faster than any rocket could have propelled it alone. This exchange is a reminder that even in the apparent emptiness of space, motion is shared. Energy moves between bodies. Nothing is isolated. The flyby of Jupiter revealed storms larger than Earth, lightning flashes in alien clouds, and moons that were anything but quiet. One of those moons, Io, turned out to be volcanically active, with plumes rising hundreds of kilometers above its surface. This was a surprise. It forced scientists to reconsider what active means in the outer solar system. But even as images streamed back and discoveries were catalogued, Voyager was already moving past Jupiter. The encounter was brief in cosmic terms. A few months of approach, a few intense days of closest observation, and then the spacecraft was flung onward. That slingshot marked a turning point in speed. Voyager was now travelling fast enough to escape the Sun entirely, It would not loop back. It would not settle into orbit. Its path was outward and permanent. Next came Saturn, another giant world with its own complexity. The journey from Jupiter to Saturn took additional years, though the gravity assist had shortened what would otherwise have been an even longer crossing. During this phase, Voyager travelled through regions of space that, once again, felt vast and largely featureless. Communication delays grew steadily. Signals that once took tens of minutes now required over an hour each way. Engineers learned to think ahead, to plan carefully, to accept that quick corrections were no longer possible. Saturn's rings, delicate and structured, offered another moment of concentrated attention. Voyager revealed fine details, gaps, waves, and small embedded moons shaping the rings through gravity. Titan, Saturn's largest moon, drew particular interest because of its thick atmosphere. Yet once more the pattern repeated. Arrival, discovery, departure. After Saturn, the mission faced a branching possibility. One Voyager probe was directed toward Uranus and Neptune, taking advantage of the rare planetary alignment. The other would follow a different path. Each option required precise timing. Missing a window by even a small margin would change everything. The crossing to Uranus was especially long. Uranus lies nearly twice as far from the Sun as Saturn does. The distance between them is measured not just in millions, but in billions of kilometres. Travelling that far meant waiting years for the next close encounter. It is difficult to truly grasp how empty that path was. No planets to observe, no dramatic gravitational dances, just the spacecraft and the Sun separated by an ever-growing gulf. When Voyager finally reached Uranus, it found a world tilted dramatically on its side, with a faint ring system and moons that appeared dark and cold. Neptune followed, even farther still with its own deep blue hue and powerful winds. Neptune was the last of the giant worlds. Beyond it lay no more major planets. Pluto, though now classified differently, was not part of Voyager's trajectory. After Neptune, there would be no more dramatic planetary flybys. Looking back, the long crossing to the giant world served two purposes. It gave us detailed knowledge of these distant planets, transforming them from vague points of light into places with character and activity. But it also quietly prepared us for something else. It taught us how far apart things really are. The gap between Jupiter and Saturn alone is greater than the distance from Earth to the Sun. The gap between Saturn and Uranus is larger still. Each crossing stretched our patience, forced our calculations to adjust, and reminded us that space is not scaled to human convenience. During these years, Voyager's speed relative to the Sun remained extraordinary. It was moving faster than any human-made object had before, and yet, even at that speed, years passed between major events. This is the lesson that numbers often fail to convey. Even when travelling faster than anything we have ever built, the solar system does not shrink into something manageable. It remains expansive, resistant to compression in the imagination. By the time Voyager completed its encounters with the giant planets, it had effectively demonstrated that the inner solar system is only a small portion of the Sun's domain. The true extent lay far beyond. The gravity assists had given Voyager the energy needed to leave the familiar structure of planetary orbits behind. Its trajectory was now aimed toward the outermost regions shaped by the Sun's influence, a region far less visible and far more extended. In a sense, the long crossing to the giant worlds was the last phase in which Voyager's journey resembled a traditional expedition. There were targets, close passes, bursts of imagery. Beyond that, the mission would transform into something slower and more abstract. As you rest and follow this story, it may help to picture those long crossings not as empty stretches, but as demonstrations. Demonstrations of how little our everyday sense of distance applies beyond Earth. Demonstrations of how persistence matters more than speed when the scale is this large. Voyager did not rush. It could not. It moved at extraordinary speed by human standards, Yet the solar system absorbed that speed effortlessly, offering more space, more distance, more room to travel. And when Neptune finally fell behind, the crossing to the giant worlds was complete. The solar system no longer presented recognizable landmarks ahead. At a certain point in Voyager's journey, something quietly deceptive revealed itself. It wasn't a discovery announced in a press release or a sudden change in instrument readings. It was a realization that crept in slowly, almost uninvited as years passed and the spacecraft continued to move without encountering anything new or familiar. The planets, it turned out, had always been misleading us. Not in their behavior and not in their physics, but in how close together we imagined them to be. From childhood onward, most of us are introduced to the solar system through images that are designed to be helpful, not accurate. The Sun sits comfortably in the centre, surrounded by neat rings. Mercury, Venus, Earth, Mars, then the giants further out. Everything fits on a single page. Sometimes Pluto hangs at the edge like a shy afterthought. The message is subtle but powerful. The solar system is something you can take in at a glance. Voyager dismantled that illusion, not by arguing with it, but by simply travelling through the space those diagrams quietly erase. Between each planet lies an emptiness that is difficult to emotionally register until something has to cross it. When Voyager left one planet behind and began the long coast toward the next, the wait was not a pause in the mission, it was the mission. Months turned into years. Telemetry arrived steadily, but nothing about the environment changed in a way that felt dramatic. Space looked like space. The sun grew dimmer, the spacecraft kept moving. And this happened again and again. The illusion of planetary closeness comes from compression. To show all the planets on one page, the distances must be squeezed until they are no longer meaningful. Jupiter ends up looking like a near neighbour of Mars. Saturn appears just a short hop away from Jupiter. Uranus and Neptune seem like distant cousins, but still part of the same immediate family. Voyager showed us that this family is spread across an enormous territory. Consider this gently. If Earth were reduced to the size of a grain of sand, the Moon would be several centimetres away. That already feels farther than most people expect. Now imagine Jupiter on that same scale. It would be hundreds of meters away. Saturn would be nearly twice that distance. Uranus and Neptune would be separated by distances measured in kilometers. And beyond them, there would still be nothing for a very long time. When Voyager crossed those distances, it did so at speeds that no human vehicle had ever achieved. Faster than bullets, faster than any spacecraft before it. And still, the time required was immense. This is the first crack in the illusion. Speed does not rescue you from scale. The second crack comes from repetition. Once, you might forgive a long crossing as an anomaly. Twice, it becomes a pattern. By the time Voyager had completed multiple multi-year crossings between planetary encounters, it became impossible to deny that the solar system is not a cluster of nearby objects, but a sparse distribution of islands embedded in a sea of space. The planets dominate our attention because they are where things happen. They have surfaces, storms, rings, and moons. They offer contrast. Between them, space offers almost none of that. No horizons, no textures, no markers to tell you how far you've gone. Voyager did not pass signposts that said halfway to Saturn or entering Uranus's neighbourhood. It simply moved and the numbers in mission logs increased steadily. From Earth, those numbers feel abstract. Millions of kilometres, billions, astronomical units stacked on top of each other. But for the spacecraft, there was no abstraction. Every metre had to be crossed. The illusion of closeness also comes from how quickly we can name the planets. We can list them in seconds. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. The ease of that list hides the enormity of the space between each word. Voyager gave time back to those gaps. As the spacecraft travelled farther from the Sun, Another subtle effect reinforced this lesson. Communication delays increased steadily. Early in the mission, commands could be sent and responses received within manageable timeframes. By the time Voyager was crossing the outer planetary distances, every interaction became a long conversation with silence built in. You would send a command, then you would wait, and only later would you learn whether the spacecraft had received it and responded correctly. This enforced patience mirrors the physical reality of the distance involved. You cannot rush a signal across billions of kilometers. You cannot shorten the gap by wanting it to be smaller. The illusion of planetary closeness also affects how we think about the Sun's influence. We often imagine that the planets neatly define the solar system, that once you pass the last planet, you are more or less outside. Voyager demonstrated how deeply wrong that assumption is. The planets occupy only the innermost portion of the Sun's domain. They are like bright beads near the centre of a much larger structure. Beyond them, the Sun's influence continues, shaping space in quieter, less visible ways. The solar wind does not stop at Neptune. The Sun's magnetic field does not end with the last orbit. These effects extend outward for distances that dwarf the planetary system itself. This means that even as Voyager left Neptune behind, it was still very much within the solar system. It was nowhere near the true boundary. The illusion that the planets mark the edge fell apart completely. Another contributor to this illusion is the way time is presented in mission summaries.
We might read that Voyager reached Jupiter in 2 years, Saturn a couple of years later, Uranus and Neptune after that. The years blend together. The waiting disappears into a sentence. Living through that waiting is different. For the engineers and scientists tracking Voyager, years passed between major milestones. Careers advanced, teams changed. New generations of scientists joined projects that had begun before they finished school. The mission became something that outlived individual expectations. This human timescale contrast further emphasized how misleading our intuitive maps are. If something takes years to reach at record-breaking speed, it is not close in any meaningful sense. Voyager also highlighted how much of the solar system's volume contains almost nothing detectable. This does not mean it is truly empty. There are particles, fields, dust, and radiation, but these are not things our senses evolved to notice. We are drawn to objects, to surfaces, to things we can point at. The vast majority of the solar system offers none of that. Between planets, there is space so empty that even a spacecraft can travel for years without encountering anything that demands attention. No collisions, no dramatic interactions, just steady motion through a thin environment. This emptiness is part of why the illusion persists. We are not good at appreciating what we cannot see or touch. Voyager made the invisible visible through persistence, through data that accumulated slowly.
Through long stretches where nothing happened in the way we're accustomed to defining events. As you rest and listen, there is something calming about this realization. The solar system is not crowded, it is spacious. It allows things to drift, to move without urgency. The illusion of closeness collapses further when you consider how small the planets themselves are compared to the distances between them. Even Jupiter, enormous by planetary standards, occupies a tiny fraction of the space it sits within. If the solar system were a city, the planets would be small houses separated by vast fields, forests, and empty land. You would not walk from one to the next. You would travel for days, perhaps weeks, without seeing another structure. Voyager did exactly that. This realization matters because it reframes how we think about exploration. Reaching another planet is not like visiting a nearby country. It is more like crossing an ocean so large that the departure point fades from memory before the destination appears, and even then that destination is brief. Voyager's encounters with planets were intense but short-lived. Days or weeks of focused observation, followed by years of travel. The imbalance is striking. The waiting dominates, the events punctuate it. This pattern is not accidental. It is built into the structure of the solar system itself. By the time Voyager had completed its planetary tour, the illusion of closeness had been thoroughly dismantled for those paying attention. The planets no longer felt like a tight-knit group. They felt like widely spaced milestones along an immense path. This understanding sets the stage for what comes next. If the planets are this far apart and if they occupy only the inner portion of the solar system, then the regions beyond them must be larger still. The solar system is not defined by the spacing of its planets. It is defined by the reach of its star, and that reach extends into regions where even Neptune begins to feel like a neighbour rather than an outpost. Voyager's slow, steady crossing between worlds was not just travel. It was a lesson delivered 1 kilometre at a time, a correction to the tidy diagrams, a reminder that convenience and accuracy are rarely the same thing. As Voyager continued outward, leaving planetary orbits behind entirely, this lesson would deepen. The idea of closeness would lose meaning altogether. Distances would no longer be framed by objects at all, but by changes in the environment itself. For now, it is enough to let the illusion fall away gently. The solar system is vast. The planets are far apart, and Voyager, by simply taking the time to move between them, showed us that our mental shortcuts had always been hiding the true scale. A scale that would become even more apparent as the familiar landmarks faded and the sun's domain stretched on, far beyond anything those early diagrams ever suggested. There comes a stage in Voyager's journey when the sun begins to change character. Not suddenly, and not in a way that would be obvious if you were standing beside the spacecraft, but gradually, as distance accumulates and familiarity loosens its grip. The sun does not disappear. It does not shrink into nothing. Instead, it slowly loses its authority. Closer in, the sun defines everything. It is the source of light, warmth, gravity, and motion. The planets move to its rhythm. Space itself feels arranged around it. Even when you cannot see it directly, you feel its presence in every calculation, every orbit, every shadow. Farther out, that certainty softens. By the time Voyager had passed beyond the giant planets and continued into the quieter reaches, the sun was no longer the overwhelming presence it once had been. It still dominated gravity locally. It still filled the sky with light, but it no longer felt unique. It began to resemble something else entirely. It began to resemble a star. This shift is one of the most difficult to feel from Earth, because we live so close to the sun that it defines our experience of space completely. Our days are structured around it. Our climate depends on it. Our very language treats it as singular. The sun rises. The sun sets. The sun shines. Voyager revealed something quietly unsettling. Out there, the sun is not special in the way it feels from here. It is one star among many, surrounded by others that are just as real, just as massive, and sometimes far more powerful. This realization does not arrive all at once. It emerges through subtle measurements and slow changes. One of the earliest indicators comes from light itself. Sunlight spreads outward in all directions, thinning as it goes. This follows a simple physical rule. Double the distance and the light spreads over 4 times the area. Triple the distance and it spreads over 9 times the area. By the time Voyager reached the outer reaches beyond the planets, sunlight was no longer a dominant force. There was still light, of course, enough to be measured, enough to be detected, but not enough to matter in the way it once did. Voyager did not rely on sunlight for power. It could not. Solar panels would have been useless at these distances. Instead, the spacecraft carried its own internal energy source, slowly converting heat from radioactive decay into electricity. That quiet, steady power allowed Voyager to function in an environment where sunlight was more of a background glow than a driving force. This is the first way the sun begins to feel ordinary. When it is no longer the primary source of energy, it becomes one influence among many. Another change comes from the sky itself. Near Earth, the sun dominates the sky. Even when it is not visible, its brightness shapes everything. The stars fade during the day. The moon reflects its light. Shadows exist because of it. Far from the sun, the sky becomes different. The sun still shines, but it no longer overwhelms the stars. Starlight becomes more noticeable. The background of the galaxy grows more present. If you could somehow look up from Voyager's position, the sun would no longer command attention. It would appear as a bright point, yes, but not dramatically different from other bright stars. Sirius, Vega, and others would share the sky on more equal terms. This is not because the sun has changed. It is because perspective has. The sun's apparent importance is a function of distance. Move far enough away, and its uniqueness fades. Voyager carried that perspective outward, kilometre by kilometre, year by year. There is something quietly humbling about this. From Earth, the sun feels like the centre of everything. From far away, it becomes one object in a crowded galaxy. Voyager's instruments also detected changes in the particles surrounding it. The solar wind, that continuous stream of charged particles flowing outward from the sun, grew weaker as distance increased. Its density dropped. Its pressure diminished. Closer in, the solar wind dominates space. It pushes outward relentlessly, shaping the environment. But farther out, it begins to encounter resistance. Particles from interstellar space push back. The sun's influence no longer expands freely. It negotiates. This interaction marks the beginning of a transition. The space around Voyager was no longer shaped exclusively by the sun. The galaxy was beginning to assert itself. This is another way the sun becomes just another star. Its influence meets limits. It competes with the collective environment between stars, an environment shaped by countless suns over immense periods of time. The sun still matters. Its gravity still holds the planets. Its wind still flows, but it no longer feels alone. From Earth, it is easy to forget that the sun is not isolated. It exists within a galaxy filled with stars, gas, dust, and magnetic fields. We rarely feel that context because the sun's influence shields us from it. Voyager moved beyond that shield. As the spacecraft continued outward, measurements showed increasing signs of the interstellar medium. This medium is not empty. It contains sparse gas, charged particles, and magnetic fields that permeate the galaxy. It is shaped by ancient supernovae, stellar winds from other stars, and the slow circulation of matter through the Milky Way. Inside the sun's domain, this interstellar environment is pushed aside. Outside, it dominates. Voyager was approaching the region where these two influences meet, a place where the sun's outward pressure balances the inward pressure of the galaxy. This boundary is not sharp. It is not a wall. It is a broad, shifting region that responds to changes in solar activity and the surrounding interstellar environment. Voyager would take years to traverse it. During this time, the sun's identity continued to change. It was no longer the unquestioned ruler of space. It became a participant in a larger system. This realization has consequences for how we think about the solar system itself. If the sun is just one star among many, then the solar system is not a unique island floating in isolation. It is a small bubble carved into a much larger structure. From Voyager's perspective, the solar system began to feel less like a complete system and more like a local variation within the galaxy. A region where one star's influence temporarily dominates, before blending back into the general environment. There is something comforting in this, even if it feels unsettling at first. The sun does not lose its importance to us. It still defines our lives, but it gains context. It becomes part of something larger. This context matters because it reframes distance. The distances Voyager travelled within the solar system were enormous by human standards. but compared to the distances between stars, they were modest. As the Sun became just another star, the scale of the galaxy began to assert itself in Voyager's data. The environment no longer reflected a single source of influence. It reflected a collective one. Another subtle effect of this transition involves time. Near Earth, changes in solar activity can be felt relatively quickly. Solar storms affect satellites. Solar cycles influence space weather. Farther out, those changes arrive later, diluted and altered by distance. Voyager detected variations in the solar wind that reflected events at the Sun many months earlier. Cause and effect were stretched across vast distances. The Sun's actions echoed outward long after they occurred. This delay further weakened the sense of immediacy. The Sun was no longer something happening now. It became something that had happened long ago, with effect still rippling outward. That sense of temporal distance mirrors the physical distance. The Sun's presence became something you inferred rather than experienced directly. As Voyager continued, the stars themselves became more meaningful reference points. The spacecraft's position could be described relative to the Sun, but also relative to the surrounding galaxy. The Milky Way was no longer just a backdrop, it was an environment. This is another moment where our intuition struggles. We are used to thinking of the solar system as a complete thing. Voyager showed us that it is more like a neighbourhood within a city. The Sun is our local star. Its planets are its immediate companions. But beyond them lies a shared space shaped by many stars together. There is no ceremony when this realization settles in. It arrives quietly, through data and patience. For those listening now, resting and letting the words move at an unhurried pace. This part of the journey offers a gentle shift in perspective. The Sun does not disappear. It simply steps back. Its warmth, which once defined the spacecraft's environment, becomes negligible. Its light, once dominant, becomes one glow among many. Its wind, once uncontested, meets resistance. And yet, Voyager continues to carry the Sun's story with it. The golden record, the signals, the knowledge that this small machine was built around a star that nurtured life intelligent enough to wonder about scale. In that sense, the Sun remains central, even as it becomes ordinary. This is not a contradiction. It is a layering of meaning. The Sun is central to us. It is not central to the galaxy. Voyager's journey allows both truths to exist at once. As the Sun's dominance softened, Voyager approached regions where measurements would reveal the true boundary of its influence. Regions where the transition from solar to interstellar would become unmistakable. But before that boundary could be reached, Voyager had to spend years in a space shaped by diminishing sunlight and increasing galactic presence. A space where the Sun still mattered, but no longer defined everything. Far from home, the Sun becomes just another star, and in doing so, it reveals not a loss of importance, but a gain in understanding. A clearer picture of where we are, how far we extend, and how small our local brightness is within the vast, patient glow of the galaxy, which Voyager continues to approach, one steady moment at a time. Out beyond the last familiar glimmer of planetary light, where orbits no longer offer signposts and the Sun no longer fills the sky with authority, Voyager entered a kind of space that feels emotionally different, even if the physics changes only gradually. This is the region where home does not vanish, but slowly loosens its hold, and warmth becomes something remembered rather than felt. From Earth, warmth is so constant that it fades into the background of daily life. The sun rises, the air heats, seasons shift, and we adjust without ever thinking about how dependent we are on that steady stream of energy. Even far from the sun, as long as you remain among the inner planets, sunlight still feels like a given. It might be weaker, but it is always there, filling space with light and heat. For Voyager, that assumption quietly stopped being true. As the spacecraft continued outward, the sun's warmth diminished in a way that was not dramatic but relentless. There was no moment when heaters shut off or temperatures suddenly plunged. Instead, every kilometre placed between Voyager and the Sun meant slightly less energy arriving, slightly fewer photons, slightly less influence. This fading is governed by simple geometry. Light spreads outward in all directions, and as it does, it thins. By the time Voyager had moved beyond the giant planets, sunlight was already many times weaker than what Earth receives. Beyond Neptune, it became so faint that it no longer played any meaningful role in the spacecraft's survival. Voyager was never warmed by the sun in the way a planet is. It carried its own heat source, generated by the slow decay of radioactive material inside special power units. These radioisotope thermoelectric generators produce both electricity and warmth, allowing instruments to function in an environment where external heat was scarce. Still, the sun's fading mattered. Not because Voyager needed it to survive, but because its absence marked a psychological boundary in how we think about space. Closer to home, the sun feels like an anchor. Its warmth is a reminder that you are still within reach, that the environment, however harsh, is shaped by something familiar. As that warmth fades, the environment begins to feel less like an extension of home and more like something else entirely. For Voyager, temperatures dropped steadily. Space itself is not cold in the way we experience cold on Earth. There is no air to steal heat from your skin. But objects radiate their heat away into the darkness, and without an external source of energy to replenish it, everything trends toward equilibrium with the background of space. That background is only a few degrees above absolute zero. Voyager's internal systems were carefully insulated and designed to retain heat where it was needed most. Even so, engineers had to make constant decisions about which instruments could remain active, and which would eventually have to be turned off to conserve power and warmth. This process did not happen all at once. Over the years, as the radioactive fuel slowly lost strength, instruments were shut down one by one. Cameras were turned off, certain sensors went silent. Voyager did not fail, it simplified. Each shutdown was deliberate. Each represented a choice to preserve the mission's core functions for as long as possible. Communication, navigation, and the ability to measure the surrounding environment were prioritized. Everything else became optional. This gradual fading mirrors the fading warmth of home itself. There is no clean break, no single farewell, just a steady reduction in what remains. The sun's warmth also influences the space around Voyager in subtler ways. The solar wind carries not only particles, but energy. As that wind weakens with distance, the environment becomes calmer in some respects and more exposed in others. Near Earth, the sun's influence shields us from much of the galaxy's background radiation. Its magnetic field deflects charged particles from distant cosmic sources. Farther out, that protection thins. Voyager detected changes in radiation levels that reflected this shift. Galactic cosmic rays became more prominent as the sun's shielding weakened. These high-energy particles, born from supernovae and other violent events far beyond our solar system, penetrated deeper into the region Voyager occupied. This is another sense in which warmth fades. Not just thermal warmth, but the comforting dominance of a single influence. The sun no longer set the tone for everything. The galaxy began to speak more clearly. From Earth, it is easy to imagine that space beyond the planets is simply colder and darker. Voyager showed us that it is also more exposed, less sheltered, more honest in a way. The fading warmth of home also reveals itself in time. Signals sent from Earth took longer and longer to arrive. Instructions that once felt immediate became delayed. Voyager existed increasingly in a different now than we did. When engineers sent commands, they were sending them into the past relative to Voyager's current position. When Voyager replied, it was describing conditions that no longer existed by the time we heard about them. This separation adds another layer to the idea of fading warmth. Home is not just a place. it is a shared sense of time. As that synchronization weakened, Voyager became more alone, and yet it was never abandoned. Earth continued to listen. Large antennas tracked the spacecraft's faint signal. The Deep Space Network adjusted its receivers, filtering noise, compensating for motion, and amplifying whispers into data. That act of listening across such distance is itself a kind of warmth, not physical, but intentional. Voyager's environment grew colder and quieter, but the connection remained. Another subtle effect of distance involves perspective. Near the sun, its light dominates the sky. Farther out, darkness becomes the default. The stars emerge more clearly. The Milky Way becomes less of a background concept and more of an environment. If Voyager could see in the way we do, the sun would no longer cast sharp shadows. Its light would no longer overwhelm the sky. It would simply be one bright point among many. This shift is important because it marks a psychological transition. The sun is no longer something you are inside of. It is something you are leaving behind. For humans, leaving warmth behind carries emotional weight. Warmth is associated with safety, life, and familiarity. Cold suggests distance, isolation, and endurance. Voyager embodied that endurance. The spacecraft did not react to the fading warmth. It did not slow down or falter. It continued on the same trajectory, powered by its internal sources, designed from the beginning to survive where sunlight could not help it. This design choice was not accidental. The engineers who built Voyager understood that the most interesting part of the journey might occur long after the sun ceased to be useful as a resource. In doing so, they acknowledged something profound. Exploration does not always move toward comfort. Sometimes it moves away from it. As Voyager travelled farther, the idea of home became increasingly abstract. Earth was no longer a place you could meaningfully point toward and say, there. It was a concept, a memory encoded in signals and records. The golden record aboard Voyager became more symbolic in this context. It carried sounds and images from a warm, active world, preserved on a spacecraft drifting through an environment where warmth was scarce. This contrast is striking. Laughter, music, greetings, and heartbeats recorded on a machine that would spend most of its existence in near absolute cold. And yet, that contrast is honest. It reflects the reality of our place in the universe. Warmth is rare. Life is fragile. Distance is vast. The fading warmth of home also prepares us to think differently about scale. Temperature is not just a measure of heat. It is a measure of proximity to energy sources. Near a star, warmth is abundant. Far from it, energy must be carried within. Voyager carried its warmth with it. As you rest and listen, there is something quietly grounding about this idea. The spacecraft does not complain about the cold. It does not resist it. It was built with the expectation that warmth would fade, and it adapted accordingly. That expectation mirrors a broader truth. Our sense of comfort is local. Our assumptions about safety and familiarity are shaped by where we evolved. The universe is under no obligation to provide them elsewhere. Voyager's journey through the fading warmth is not a story of loss. It is a story of transition, of adjusting to an environment that does not cater to life or ease. The sun still mattered. Its gravity still shaped Voyager's path. Its wind still flowed outward, but its warmth no longer defined the spacecraft's existence. This is the moment when the solar system begins to feel less like an extension of home, and more like a region being passed through. Ahead lay boundaries that would be defined not by temperature, but by pressure, particles, and magnetic fields. Boundaries where the sun's influence would be measured against the galaxy itself. Before reaching those regions, Voyager had to spend years in a space where warmth was fading but not gone, where home was distant but not forgotten. This in-between state is important. It teaches patience. It teaches adaptation. It teaches us that leaving does not happen all at once. For Voyager, the fading warmth of home was not an ending. It was preparation. a gradual acclimation to an environment where survival depended entirely on internal resilience rather than external support. If you imagine the solar system as a tidy structure with a clean outer wall, this is the moment when that picture quietly falls apart. There is no fence, no glowing boundary line, no sudden drop from inside to outside. What Voyager approached was something far more subtle, and in many ways, far more interesting. For centuries, people naturally assumed that systems must end the way objects do. A shoreline marks the end of land. A city limit sign marks the end of a town. Even a planet has a surface you can point to and say, here is the boundary. It feels intuitive that the solar system should have something similar, a final edge beyond which it simply stops. Voyager revealed that this expectation is misleading. The sun does not draw a hard line in space. Instead, it creates a sphere of influence that thins gradually as distance increases. That sphere is shaped not just by gravity, but by the solar wind, the continuous stream of charged particles flowing outward in all directions. Think of the solar wind as a slow, invisible exhale. The sun releases it constantly, and it expands outward into interstellar space, carrying the sun's magnetic field with it. This outflow forms a vast bubble around our star, a region where the sun's influence dominates over the surrounding galaxy. That bubble is called the heliosphere. The heliosphere is not small. It extends far beyond the orbit of Pluto, far beyond the Kuiper Belt, and into a region that Voyager would take decades to reach. It is shaped by the balance between the outward pressure of the solar wind and the inward pressure of the interstellar medium, the sparse gas and particles that fill the space between stars. Where these pressures meet, something interesting happens. The solar wind slows down, its particles pile up slightly, its motion becomes less smooth, but it does not stop instantly. This is why the edge of the solar system is not an edge at all. It is a transition zone, a broad, shifting region where the sun's influence gradually yields to that of the galaxy. As Voyager travelled outward, its instruments began to detect changes in the solar wind's behaviour. Speeds decreased, particle densities fluctuated, magnetic fields twisted in subtle ways. These changes did not happen overnight, they unfolded over years. The first major region Voyager encountered in this transition is called the termination shock. This is the point where the solar wind, which has been racing outward at supersonic speeds, slows abruptly due to pressure from the interstellar medium. Shock might suggest something dramatic like a collision. In reality, it is more like traffic slowing down as it approaches congestion. The particles compress, adjust and continue, but at reduced speed. Voyager crossed this region quietly. There was no jolt, no visible marker, only instrument readings showing that something fundamental had changed. Beyond the termination shock lies the heliosheath. This is a vast region where the solar wind continues outward, but more slowly and more turbulently. It is like a buffer zone between the inner heliosphere and the true boundary with interstellar space. Voyager spent years crossing the heliosheath. This fact alone challenges our sense of scale. Years inside a boundary region. Years moving through a zone that, in a simple diagram, might be drawn as a thin line. The heliosheath is not thin. It is enormous, and its size is not fixed. It expands and contracts depending on the sun's activity. During periods of high solar output, the heliosphere swells. During quieter periods, it shrinks. This means that the edge of the solar system is dynamic. It breathes. Imagine trying to define the edge of a cloud while it shifts shape constantly. Any boundary you draw would be temporary. Voyager's measurements during this time were crucial. They showed that the heliosphere is not smooth or uniform. It contains variations, ripples, and fluctuations driven by both solar activity and the surrounding interstellar environment. The spacecraft detected changes in particle populations. Galactic cosmic rays became more prominent as the solar wind's shielding effect weakened. The balance between solar origin particles and interstellar origin particles shifted gradually. Still, there was no clear moment of departure. Engineers and scientists watched the data carefully, waiting for signs that Voyager had reached the heliopause, the boundary where the solar wind's outward push is finally balanced by the inward pressure of the interstellar medium. Even that boundary is not sharp. The heliopause marks a region where the density and composition of particles change noticeably. Solar particles drop off, interstellar particles increase, magnetic field orientations adjust. Voyager eventually crossed this region, but even then the transition was not visually dramatic. It was inferred from data, a shift in particle counts, a change in magnetic field characteristics, a measurable increase in cosmic rays. This subtlety is important. The solar system does not end with a bang. It fades into the galaxy. From Earth, we tend to think in binaries, inside or outside, here or there. Voyager's journey forces us to adopt a gradient instead. This gradient reshapes how we understand our place in space. If there is no clear edge, then the solar system is less like a walled garden and more like a region of influence within a larger environment. That larger environment, the interstellar medium, is not empty. It contains gas atoms, charged particles, and magnetic fields shaped by countless other stars. It is the shared space of the galaxy. Voyager's crossing into this region marked the first time a human-made object entered true interstellar space, but even that statement requires nuance. Voyager is still gravitationally bound to the Sun. Its trajectory is shaped by the Sun's pull. It will orbit the centre of the Milky Way alongside our star for billions of years. So in one sense, it is still part of the solar system. In another, it has left the Sun's direct plasma environment. This ambiguity reinforces the idea that the edge is not an edge. It depends on what you mean by solar system. If you define it by planets, Voyager left long ago. If you define it by the heliosphere, it crossed more recently. If you define it by gravity, it has not left at all. Boundaries in space are often conceptual rather than physical. There is something quietly calming about this realization. The universe does not organize itself into neat categories for our convenience. It transitions gradually, blending one region into another. As Voyager moved through the heliosheath, signals continued to arrive on Earth, delayed by many hours. Each one carried information about particle energies, densities, and magnetic field directions. Scientists debated whether the spacecraft had truly crossed into interstellar space. The data was complex. Some indicators suggested it had. Others seemed to contradict that conclusion. This uncertainty lasted for months. Eventually the evidence accumulated. The particle environment had changed in a sustained way. Cosmic rays from outside the solar system dominated. Solar particles diminished. The magnetic field showed characteristics consistent with the interstellar medium. Voyager had crossed the heliopause, yet even in that moment there was no visual confirmation, no photograph of a line drawn in space, only numbers and patterns. The edge that isn't an edge became real through patience and interpretation. As you lie there now, letting this story unfold at a steady pace, consider how often we look for sharp boundaries in our own lives. Clear endings, definitive transitions. The universe rarely provides them. Voyager's journey shows us that departure can be gradual, that influence can fade rather than snap, that leaving one environment and entering another may take years, not moments. The heliosphere still surrounds the Sun. It still protects the inner planets from much of the galaxy's radiation. It still expands and contracts with solar cycles, but Voyager now resides in a region where the galaxy speaks more loudly than our star. This does not mean it is lost. It means it has entered a broader context. The solar system, once imagined as a compact arrangement of planets, now appears as a bubble within a vast sea. Its boundary is not a wall, but a negotiation between forces, and Voyager, by simply continuing forward, made that negotiation visible. The edge that isn't an edge is one of the most important lessons of this journey. It reminds us that scale is not only about distance, it is about gradients, about how influence weakens and strengthens over space. As Voyager continues deeper into interstellar territory, it carries with it the memory of the sun's domain, and the evidence that boundaries in the cosmos are rarely as sharp as we once assumed. Long before any boundary could be named with confidence, before anyone could point to a graph and say, "This is where it happens," Voyager began to experience the first undeniable sign that the sun's outward reach was no longer unchallenged. The change did not arrive with spectacle. It did not announce itself. Instead, it appeared as a quiet alteration in behaviour, subtle enough that only careful instruments and patient analysis could reveal what was going on. This moment is known as the crossing of the termination shock, and despite how dramatic the phrase sounds, it is not a collision in the way we instinctively imagine one. Nothing crashed. Nothing broke. Voyager did not strike a wall. What happened was far more restrained and far more instructive. To understand why the termination shock matters, it helps to think again about the solar wind. The sun constantly releases a stream of charged particles, mostly protons and electrons, flowing outward in all directions. Near the sun, this flow is energetic and fast, moving at hundreds of kilometers per second. It is this wind that inflates the heliosphere, carving out a cavity in the interstellar medium. For a long time, as Voyager travelled outward, that wind behaved predictably. It streamed past the spacecraft, its properties changing gradually with distance, but always maintaining its outward rush. The sun was still firmly in charge, but the solar wind does not expand into a vacuum. Far beyond the planets, it begins to encounter resistance. The interstellar medium presses back, not with forceful impact, but with persistent presence. Particles from outside the solar system exert pressure of their own. Magnetic fields intersect and interact. Eventually, the outward flow of the solar wind can no longer maintain its speed. That slowing is the termination shock. A shock, in physics, does not have to be violent. It simply describes a situation where a flow changes speed abruptly. In this case, the solar wind transitions from supersonic speeds to subsonic ones. It goes from rushing freely to pushing through resistance. Voyager crossed this region not once, but twice, because the boundary itself moves. This is an important detail that often gets overlooked. The termination shock is not fixed in space. Its distance from the sun changes as solar activity rises and falls. When the sun is more active, the solar wind is stronger, and the shock is pushed farther out. When the sun quiets down, the shock moves inward. As a result, Voyager encountered the termination shock during a period of changing solar conditions. The spacecraft crossed into the region, then later crossed back out as the boundary shifted, and then crossed it again. Each crossing provided valuable data. The instruments on board Voyager detected changes in particle speeds, densities, and energies. The once fast solar wind slowed noticeably. Its temperature increased as kinetic energy was converted into heat. Turbulence increased. This turbulence is another reason the termination shock does not feel like a clean edge. Instead of a smooth transition, the environment becomes messy. Particles scatter. Magnetic fields twist and fluctuate. Conditions vary from one moment to the next. From Earth, scientists watch these changes unfold with cautious excitement. This was not just another milestone. It was the first direct measurement of a region that had been theorized for decades but never observed directly. Until Voyager, everything we thought we knew about the termination shock came from models and indirect evidence. Now, for the first time, we had a probe moving through it, measuring it from the inside. What those measurements showed challenged simple expectations. The termination shock was not where some models predicted it would be. It was closer to the sun than expected in some directions, farther in others. It was asymmetric, shaped by the local conditions of the interstellar medium and the orientation of magnetic fields. This asymmetry matters because it tells us that the solar system is not moving through space evenly. Our sun is travelling through the galaxy, encountering regions of varying density and pressure. The heliosphere is shaped by that motion. In other words, the solar system has a kind of wind of its own, flowing around it as it moves through the Milky Way. Voyager's crossing of the termination shock revealed this interaction in real time. The data also showed that energetic particles behaved in unexpected ways. Some particles appeared to be reflected back toward the inner solar system. Others gained energy through complex interactions near the shock. This region turned out to be an important accelerator of particles, contributing to populations of energetic ions that had puzzled scientists for years. None of this was obvious at first glance. It took months and years of careful analysis to piece together what Voyager was telling us. Graphs were compared, models were revised, assumptions were questioned. All the while, Voyager kept moving. From the spacecraft's perspective, nothing special happened. It did not slow down. It did not change course. It simply passed through a region where the environment behaved differently. This is one of the most striking aspects of the termination shock. It exists entirely in the behaviour of invisible things. You could pass through it without ever knowing, unless you were equipped to measure the subtle details of particle motion and magnetic fields, and yet its significance is profound. The termination shock marks the beginning of the end of the sun's unchecked influence. Beyond it, the solar wind no longer dominates. It still flows outward, but it is constrained, slowed, and reshaped. This is the first point where the sun is forced to compromise. For listeners resting now, letting this idea settle without urgency, there is something quietly reassuring about that compromise. Even stars have limits. Even powerful, long-lived sources of energy must eventually negotiate with their surroundings. The sun does not rule indefinitely. It participates. Voyager's crossing also underscored how large the solar system really is. The termination shock lies far beyond the orbit of Neptune. Crossing it required decades of travel at record-breaking speeds, and even then, crossing it did not mean leaving the solar system. This distinction is important. The termination shock is not the boundary of the heliosphere, it is the beginning of a buffer zone. Beyond it lies the heliosheath, a vast region where the slowed solar wind continues outward, interacting chaotically with the interstellar medium. Voyager would spend years in that region. So even after crossing the termination shock, the journey was far from over. The solar system still extended outward for a distance comparable to the entire planetary region many times over. This realization further dismantles the idea of neat boundaries. If the termination shock were the edge, the story would be simpler. But it is not. It is a threshold into complexity. Another subtle aspect of the termination shock involves time. Changes at the sun take years to propagate outward to this region. When Voyager detected variations in the solar wind near the shock, those variations reflected solar conditions from long ago. This creates a layered timeline. Voyager was measuring the sun's past while Earth was experiencing its present. The solar system, in a sense, contains multiple versions of the sun at once spread across space. That idea alone reshapes how we think about distance. Space is not just separation, it is delay. It is history stretched thin. The termination shock is where that stretching becomes impossible to ignore. Engineers monitoring Voyager knew that power was slowly declining. Instruments had to be prioritized. Every measurement taken in this region was precious, because there would be no second chance. The spacecraft was doing something no other human-made object had done. It was measuring the environment at the far reaches of the sun's influence, directly and continuously. As Voyager crossed and recrossed the termination shock, the data accumulated into a picture that was richer and more complex than expected. The boundary was dynamic. The region was turbulent. The interaction between solar and interstellar forces was ongoing, not settled. This dynamism tells us something important about scale. Large structures are not static. They evolve, breathe, and respond to changes both internal and external. The solar system, often imagined as a clockwork mechanism, turns out to be more fluid at its edges. Voyager's experience at the termination shock forced scientists to abandon overly simple models. The heliosphere could not be described as a smooth bubble with a clear outline. It was irregular, responsive, and shaped by forces beyond our star. This realization feeds directly into a deeper understanding of what comes next. Beyond the termination shock lies a region where the sun's influence continues to weaken, where the solar wind is slowed and heated, and where interstellar particles increasingly assert themselves. The termination shock is the first step into that region, a warning sign, not an exit sign. For those listening now, allowing this story to move at an unhurried pace, it may help to think of the termination shock not as dramatic crossing, but as a change in tone. The music of the environment shifts, the dominant instrument softens, others begin to be heard. Voyager listened to that shift with its sensors, translating invisible interactions into numbers we could study. As the spacecraft continued onward, the solar wind behind it still flowed, still carried the sun's signature. Ahead of it lay a region where that signature would become increasingly faint. Crossing the termination shock was not the end of anything. It was the beginning of a longer, quieter passage through a place where the sun no longer spoke with a single, confident voice. Between the certainty of the sun's inner reach and the vast openness of interstellar space lies a region that does not announce itself loudly, yet quietly reshapes everything that passes through it. This is the heliosheath, and entering it marked a profound change in Voyager's environment. Not because something suddenly happened, but because everything began to behave differently. After crossing the termination shock, Voyager did not arrive anywhere recognizable. There was no sense of completion, no feeling of having reached a destination. Instead, the spacecraft drifted into a zone where the rules softened, where the solar wind no longer surged confidently outward, and where the influence of the galaxy began to press in with patience rather than force. The heliosheath exists because the solar wind does not simply stop when it slows down. Once it passes through the termination shock, it continues outward, but now at reduced speed and increased temperature. The particles become more chaotic, their paths tangle, the once smooth flow turns restless and uneven. This region is vast, larger than the entire planetary system many times over. Voyager would spend years crossing it, and during that time the spacecraft provided the first direct measurements of a place scientists had only imagined before. From a distance, the heliosheath might sound like a boundary layer, a thin skin between two environments. In reality, it is more like a wide, unsettled frontier. The solar wind, weakened but persistent, pushes outward. The interstellar medium pushes inward. Neither fully dominates. As Voyager entered this region, its instruments detected an increase in turbulence. Particle densities fluctuated. Magnetic fields twisted and shifted orientation. Conditions changed over time, responding both to solar cycles and to the surrounding galactic environment. This turbulence is not violent. There are no explosions, no sudden disruptions. Instead, it is slow and complex, like currents mixing in deep water. Motion exists, but it is subtle. Energy is redistributed rather than released. The heliosheath challenges our instinct to think of space as static. Even far from planets, even beyond the sun's confident reach, space is active. It is shaped by competing pressures and long-term interactions. One of the most striking features Voyager detected in the heliosheath was the changing balance of particles. Solar origin particles, once dominant, became less prevalent. Interstellar particles grew more common. Galactic cosmic rays, high-energy particles born from distant supernovae and other energetic events, penetrated deeper into the region. This shift did not happen overnight. It unfolded gradually, reinforcing the idea that the solar system fades rather than ends. For scientists on Earth, interpreting this data required patience. The heliosheath did not behave uniformly. Measurements varied depending on direction, time, and solar activity.
Models had to be adjusted repeatedly. This complexity revealed something important. The heliosphere is not a symmetrical bubble. It is shaped by the sun's motion through the galaxy, by the local density of interstellar material, and by magnetic fields that extend far beyond our star. In some directions, the heliosheath is thicker, in others, thinner. Voyager's path represented just one slice through a much larger, irregular structure. As the spacecraft continued onward, communication delays grew longer still. Signals took more than half a day to travel between Voyager and Earth. Planning operations required foresight measured in weeks. Mistakes could not be corrected quickly. This enforced a kind of calm discipline. Commands were carefully bundled. Instruments were scheduled with precision. There was no room for improvisation. That slow rhythm matched the environment Voyager was traversing. Nothing in the heliosheath moved quickly. Changes accumulated over long periods. Stability came not from stillness, but from balance. The quiet nature of this frontier makes it easy to underestimate its importance. But the heliosheath plays a crucial role in protecting the inner solar system. It acts as a buffer, slowing and deflecting a significant portion of incoming galactic radiation. Without it, Earth and the other planets would be exposed to far higher levels of cosmic rays. Life as we know it would face a harsher environment.
Voyager's journey through the heliosheath allowed us to measure that protection directly, to see how effective it is, how it varies, and how it responds to changes in solar output. Another subtle aspect of the heliosheath involves energy transformation. As the solar wind slows and compresses, its energy does not vanish. It is converted into heat and turbulence. Particles gain random motion. Magnetic fields store and release energy in complex ways. This process contributes to the overall structure of the heliosphere, shaping how it interacts with the galaxy. From Earth, these interactions feel remote and abstract. Voyager made them tangible. The spacecraft's instruments recorded increases in energetic neutral atoms, particles created when charged solar wind particles interact with neutral atoms from interstellar space. These interactions provide indirect images of the heliosphere's shape and behavior. Through Voyager and other missions, scientists began to see the heliosphere not as a smooth bubble, but as something with texture, with regions of compression and expansion, with asymmetries that reflect our sun's motion through the Milky Way. The heliosheath, then, is not just a region to cross. It is a place where information accumulates, where the solar system reveals how it fits into its larger environment. For those listening now, perhaps lying still and letting the story unfold gently, the heliosheath offers a metaphor that does not need embellishment. It is a reminder that transitions are often slow, quiet, and complex. That meaningful change does not always announce itself. Voyager did not know when it entered the heliosheath. Only later, through analysis, did scientists confirm what the spacecraft had been experiencing. This delay between experience and understanding mirrors how we often recognize change in our own lives. By the time you realize you have crossed into something new, you have often been there for a while. As Voyager continued deeper into the heliosheath, the sun's influence became increasingly muted. Its wind still flowed, but its structure was altered. Its dominance was no longer assured. Yet the sun was not absent. Its signature remained present in the particles and fields Voyager measured. The heliosheath is still part of the solar system, even as it blends into the galaxy. This dual identity makes it a fascinating place. It is neither fully solar nor fully interstellar. It belongs to both. Voyager's slow passage through this region emphasized just how large the solar system truly is. The heliosheath alone is thicker than the entire distance from the Sun to the outer planets. This fact alone challenges our intuition. If the planets occupy only the inner portion of the solar system, then most of our star's domain is something we cannot see, cannot visit easily, and rarely think about. Yet it is there, shaping our cosmic environment quietly and continuously. The The spacecraft's power continued to decline during this time. Engineers turned off additional instruments, preserving only those essential for measuring the surrounding plasma, particles, and magnetic fields. Each shutdown narrowed Voyager's senses but sharpened its purpose. The mission became increasingly focused on understanding the boundary region itself. There is something elegant about this narrowing. As Voyager approached the outer limits of the Sun's influence, it shed unnecessary complexity, becoming a simpler observer of a simpler question. Where does the solar system give way to the galaxy? The heliosheath did not answer that question cleanly. Instead, it revealed that the answer depends on how you define give way. If you mean where the solar wind slows, that happens at the termination shock. If you mean where solar particles no longer dominate, that happens gradually throughout the heliosheath. If you mean where interstellar space fully takes over, that lies ahead, beyond another subtle boundary. This layered structure is why the heliosheath matters so much. It prevents us from oversimplifying. It forces us to accept gradients instead of lines. As Voyager moved onward, it carried with it the accumulated history of the Sun's influence. Particles emitted years earlier still surrounded it. Magnetic fields stretched and twisted by solar cycles long past continue to shape the environment. Space, in this region, is a record. This idea adds another dimension to scale. Distance is not just separation, it is memory. The farther you go, the older the influences you encounter. Voyager was not just moving away from the Sun, it was moving through the Sun's past. For listeners allowing their thoughts to slow, this is a comforting notion. Nothing is truly left behind all at once. Influence lingers, effects propagate. Even as warmth fades and dominance softens, traces remain. The heliosheath embodies this lingering. It is the solar system's afterglow. As the spacecraft continued its patient drift, the environment grew increasingly dominated by interstellar characteristics. Cosmic rays rose, solar particles fell, magnetic fields began to align more with the galaxy than with the Sun. These trends pointed toward the next transition, still ahead. But that transition would not be abrupt either. It would come through subtle shifts, careful measurement, and long-term change. For now, Voyager remained in the quiet frontier, a region defined not by arrival or departure, but by overlap. The heliosheath taught us that the solar system's true scale is not measured by where planets orbit, but by how far the Sun's influence can be detected before it finally blends into the background of the Milky Way. And as Voyager continued forward, still sending its faint signal back across billions of kilometers, it carried with it the evidence that the most important boundaries in space are not walls, but wide, patient regions where forces meet, negotiate, and slowly give way to something larger. Somewhere far beyond the warmth, beyond the slowing solar wind, beyond even the long unsettled stretch of the heliosheath, Voyager approached a boundary that is defined less by location and more by balance. This boundary does not glow, does not crackle, and does not announce itself with any sense of ceremony. It exists as a quiet agreement between forces, a place where one influence finally yields to another. This place is called the heliopause. To understand why the heliopause matters, it helps to let go of the idea that it is a wall. It is not something you crash into or pass through like a doorway. It is more like a meeting point, a thin and shifting region where the outward breath of the Sun finally matches the inward pressure of the galaxy. Up until this point in the journey, the Sun's particles, even slowed and disturbed, were still pushing outward. They still carried the Sun's magnetic signature. They still defined the local environment more than anything else. The heliopause is where that stops being true. At the heliopause, the solar wind no longer wins. The interstellar medium, the sparse but persistent mixture of gas, particles, and magnetic fields that fills the space between stars, pushes back with equal strength. Neither side dominates. The result is not conflict, but equilibrium. This balance is delicate. It shifts over time. It responds to solar cycles, to changes in the local interstellar environment, and to the sun's slow movement through the Milky Way. The heliopause is not fixed in place. It moves, expands, contracts, and subtly reshapes itself. Voyager's approach to this region was not marked by a countdown. There was no moment when Mission Control knew with certainty that the crossing was imminent. Instead, scientists watched patterns in the data, looking for signs that the environment was changing in a fundamental way. Those signs were quiet. One of the clearest indicators involved particles. Inside the heliosphere, the region dominated by the Sun, the majority of detected particles originate from the solar wind. Outside, in interstellar space, particles come from distant sources across the galaxy. Their energies, directions, and behaviours are different. As Voyager moved deeper into the outer reaches, the balance between these populations shifted. Solar particles declined. Galactic cosmic rays increased. The change was not sudden, but it was persistent. At the same time, magnetic fields told their own story. Inside the heliosphere, magnetic fields are shaped primarily by the Sun. They're carried outward by the solar wind, twisted into a spiral by the Sun's rotation. Outside, magnetic fields reflect the broader structure of the galaxy. Near the heliopause, Voyager detected a change in magnetic field characteristics that suggested a transition. The orientation and behaviour of the field shifted in ways consistent with entering a new environment. Taken together, these clues painted a picture that could not be ignored. Voyager was no longer in a region controlled by the Sun alone. When scientists announced that Voyager had crossed the heliopause, the language was careful. They did not say the spacecraft had left the solar system in an absolute sense. They said it had entered interstellar space. This distinction matters. The heliopause marks the end of the Sun's direct plasma influence. Beyond it, the solar wind no longer shapes the environment, but gravity still binds Voyager to the Sun. The spacecraft will continue to orbit the centre of the galaxy alongside our star. In that sense, it is still part of the solar system's broader gravitational family. The heliopause is not a goodbye, it is a handoff. This handoff is what makes the heliopause feel like a whisper rather than a declaration. Nothing dramatic happens. There is no shockwave, no sudden darkness, no visual change. Only a slow, measurable shift in who is speaking more loudly, the Sun or the galaxy. Voyager crossed this boundary without knowing it. Only later, through months of analysis, did scientists confirm what had occurred. The crossing itself was silent. There is something profoundly fitting about that. The space between stars is unimaginably vast and mostly empty. Any boundary within it would be expected to be subtle. Loud edges belong to human imagination, not to cosmic reality. The heliopause exists because two pressures balance each other. The outward pressure of the solar wind, weakened by distance and slowed by the heliosheath, finally equals the inward pressure of the interstellar medium. At that point, neither advances. This balance creates a surface of sorts, but not a rigid one. Think of it less as a shell and more as a membrane. It flexes, it responds. It is permeable in some ways and resistant in others. Some particles cross it easily, others are deflected. Magnetic fields interact across it. Energy passes through in complex ways. Voyager's instruments were designed precisely to detect these kinds of interactions. Even with many systems shut down to conserve power, the spacecraft could still measure particle energies, densities, and magnetic field properties. Those measurements reveal that interstellar space is not empty in the way we often imagine. It contains fewer particles than the solar wind, but those particles are often more energetic. They carry information from distant parts of the galaxy. Beyond the heliopause, Voyager began sampling this galactic environment directly. For the first time, a human-made object was measuring space shaped not by our star, but by countless others. This achievement is easy to understate because nothing dramatic accompanies it. No images, no sudden change in scenery, just numbers. But those numbers represent a profound shift in perspective. For the entirety of human history, every measurement we made of space came from within the sun's protective bubble. Even our telescopes, orbiting Earth or stationed near it, were still inside the heliosphere. Voyager changed that. The spacecraft became our first outpost in true interstellar space. The heliopause also taught us something important about scale. The distance from the sun to this boundary is far greater than the distance from the sun to the planets. Many times greater. This means that when we draw the solar system as a set of planetary orbits, we are leaving out most of it. The solar system is not defined by where planets circle the sun. It is defined by how far the sun's influence extends into space. That extension is vast. The heliopause lies so far out that light itself takes many hours to travel back to Earth. Signals from Voyager take nearly a full day to arrive. Even at the speed of light, communication is slow. This delay reinforces how removed Voyager now is. Commands sent from Earth describe a past state of the spacecraft. Data received describes a past environment. There is no shared present, and yet the connection remains. Earth still listens. Voyager still speaks. The faintness of that signal is hard to overstate. By the time Voyager's radio transmission reaches Earth, it is weaker than a billionth of a watt. It must be carefully teased out of background noise by massive antennas and sophisticated processing. This effort is not strictly necessary. Voyager could be left alone, drifting silently. But we choose to listen. That choice matters. It reflects a willingness to stay connected even as distance grows almost absurdly large. It reflects patience, and it reflects curiosity that does not demand immediacy. The heliopause is also a reminder that transitions in the universe are rarely sharp. Even here, at the boundary between solar and interstellar space, the change is gradual and layered. Voyager did not suddenly stop detecting solar particles. Their numbers declined. Interstellar particles increased. The balance shifted. This overlapping period reinforces the idea that space is a continuum, not a series of compartments. The sun's influence does not vanish instantly. It lingers. The galaxy's influence does not suddenly appear. It grows. The heliopause marks the point where one finally outweighs the other. For listeners allowing this story to unfold slowly, there is something calming in that balance. It suggests that endings are often quiet, that leaving does not require force. The heliopause also reframes our relationship to the galaxy. Inside the heliosphere, the galaxy feels distant, a backdrop of stars. Outside, it becomes the environment. Voyager now exists in a space where the dominant influences come from beyond our solar system. The particles it measures have travelled from distant regions of the Milky Way. The magnetic fields reflect galactic structure rather than solar rotation. This does not make the sun irrelevant. It simply places it in context. The sun is one star among hundreds of billions. Its domain is significant locally, but limited in the grand scheme. The heliopause is where that truth becomes measurable. As Voyager continues outward, it will move deeper into interstellar space, sampling regions that no probe has visited before. Over time, the influence of the sun will become fainter still. Eventually, Voyager's power will run out. Its signal will fade. The spacecraft will become silent. But its journey through the heliopause has already reshaped how we understand the solar system's size and structure. The solar system is not a compact arrangement of planets. It is a vast bubble carved into the galaxy by a single star's wind. That bubble extends far beyond anything visible, and it fades not with a wall, but with a whisper. The heliopause stands as proof that the universe does not organize itself for our convenience. Boundaries are subtle, influence is gradual, scale is humbling. As you rest now, letting these ideas drift without needing to hold on to them tightly, it may help to picture the heliopause not as an ending, but as a quiet exchange. The sun steps back. the galaxy steps forward. Neither announces itself. Voyager crossed that exchange without fanfare, carrying with it our instruments, our curiosity, and a small record of who we were when we decided to listen this far out. Beyond the heliopause, the journey continues. The solar system's influence thins further, the galaxy's presence grows stronger, and the distances ahead stretch far beyond even what Voyager has already crossed. The word itself sounds decisive, almost final, as if it marks a clear departure from everything familiar. Interstellar, between the stars, a place name that seems to promise distance, emptiness, and a clean break from home. Yet when Voyager entered what scientists carefully described as interstellar space, the reality behind that word turned out to be far more nuanced, layered, and quietly complicated than the term suggests. To understand what interstellar actually means, it helps to let go of the idea that it describes a location you arrive at, like a city or a shoreline. Interstellar is not a destination, it is a condition, a description of which influences dominate the space around you. Inside the heliosphere, the sun speaks the loudest. Its particles, magnetic field, and radiation define the local environment. Outside that region, those solar signatures no longer dominate. The galaxy does. That is the shift Voyager made. Not from somewhere to nowhere, but from one governing influence to another. This distinction matters because interstellar space is often imagined as emptiness, a vast, silent void between stars where nothing happens and nothing exists. Voyager showed us that this picture is deeply incomplete. Interstellar space is thin, yes. The number of particles per cubic centimetre is extraordinarily low compared to anything we experience on Earth. But thin does not mean empty, and it certainly does not mean inactive. The interstellar medium is filled with matter, energy, and structure. It contains gas atoms, both neutral and charged. It contains dust grains, tiny solid particles made of carbon, silicates, and ice. It contains magnetic fields that stretch across enormous distances, and it contains radiation from countless sources near and far. Voyager's instruments began detecting this environment directly after crossing the heliopause. For the first time, measurements were no longer filtered through the sun's protective bubble. The spacecraft was sampling the raw material of the galaxy. One of the most noticeable changes involved cosmic rays. These are high-energy particles, mostly protons and atomic nuclei, that travel through space at nearly the speed of light. Many are born in violent events such as supernova explosions, where stars end their lives in massive outbursts of energy. Inside the heliosphere, the solar wind deflects and modulates a significant portion of these particles. Outside, that shielding weakens dramatically. Voyager detected a sustained increase in cosmic ray intensity, confirming that it had entered a region where galactic influences dominated. These particles carry information about distant events, sometimes thousands of light years away. In interstellar space, Voyager was bathing in the galaxy's history. This alone challenges the idea that interstellar space is quiet. It is filled with signals from across the Milky Way, constantly passing through. Another important change involved plasma density. Plasma is a state of matter where electrons are separated from atomic nuclei, creating a soup of charged particles. Inside the heliosphere, most plasma originates from the sun. Outside, it comes from the interstellar medium. Voyager's instruments measured an increase in plasma density that could not be explained by solar sources. This provided further confirmation that the spacecraft was now in a new environment. What is striking about these measurements is how subtle the transition was. There was no sudden surge, no sharp boundary. Instead, values shifted gradually and then stabilized at new levels. Interstellar space does not announce itself. It simply behaves differently. Magnetic fields also told an important part of the story. The sun's magnetic field is carried outward by the solar wind, twisted into a spiral pattern by the sun's rotation. This creates a distinct magnetic signature inside the heliosphere. Beyond the heliopause, Voyager detected magnetic fields that were no longer dominated by this solar pattern. Instead, they reflected the broader galactic field, shaped by processes occurring on scales far larger than our solar system. These fields are weak by everyday standards, but they exert influence over enormous distances. They guide the motion of charged particles. They shape the structure of interstellar clouds. They connect regions of the galaxy that would otherwise seem isolated. Voyager's entry into this magnetic environment marked another sense in which interstellar became real. The spacecraft was now embedded in the Milky Way's own fabric. It is worth pausing here to appreciate how unfamiliar this environment is to us. Every human being who has ever lived has existed inside the heliosphere. Even our most distant probes, until Voyager, remained under the sun's direct influence. Our understanding of space has always been solar-centered, even when we study distant stars. Voyager changed that by stepping outside the sun's immediate domain and letting the galaxy take over. This shift in perspective is one of the most profound aspects of the mission, and it is easy to miss because nothing dramatic accompanies it. When we hear Interstellar, we often imagine a spacecraft travelling between stars, moving from one stellar system to another. Voyager is not doing that. It is not headed toward a specific star. It is drifting through the space between stars, and that space is far larger than most people realise. The distance between stars in our region of the galaxy is measured in light years. Even travelling at Voyager's remarkable speed, it would take tens of thousands of years to approach another star closely. Interstellar space, then, is not a corridor you pass through quickly. It is the dominant environment of the galaxy. Most of the Milky Way's volume consists of interstellar space. Stars, planets, and solar systems occupy a tiny fraction of it. Voyager has entered the majority domain. This realization reframes scale in a fundamental way. The solar system, once imagined as a large structure, becomes a small bubble within an ocean that stretches across tens of thousands of light years. Interstellar space also has structure. It is not uniform. There are regions of higher density and lower density. Clouds of gas and dust form and disperse. Shock waves from supernovae propagate through it. Star formation begins in dense pockets, where gravity overcomes pressure. Voyager is currently travelling through a relatively calm region known as the local interstellar cloud. This cloud is part of a larger complex of interstellar material that the Sun happens to be moving through at this point in its galactic orbit. This means that interstellar conditions are not fixed. As the Sun moves around the Milky Way, it passes through different regions of interstellar space, each with its own density, temperature, and magnetic properties. Over millions of years, the heliosphere itself changes shape in response to these environments. It expands in some regions and compresses in others. The size of the solar system, defined by the Sun's influence, is not constant over geological time. Voyager's measurements provide a snapshot of this interaction at a particular moment in the Sun's journey through the galaxy. Another misconception about interstellar space is that it is timeless, that nothing changes. In reality, interstellar space evolves constantly, just on timescales that dwarf human experience. Gas clouds collapse to form stars. Stars explode and seed space with heavy elements. Magnetic fields twist and reconnect. Radiation permeates everything. Voyager is moving through this environment, sampling it slowly, steadily, without urgency. Its instruments detect changes over years rather than seconds. Subtle trends matter more than dramatic events. Communication delays now stretch close to a full day. When Voyager sends data, it describes conditions that existed many hours earlier. Earth receives those descriptions long after the spacecraft has moved on. This delay adds another layer to what interstellar means. It is not just physical distance, it is temporal separation. Cause and effect are stretched across time in ways that feel unfamiliar. From Earth, we often think of space exploration as something that happens in near real time. Images arrive quickly, commands are executed promptly. Voyager's interstellar journey makes that impossible. Operations become predictive rather than reactive. Engineers plan far ahead. They trust models. They wait. That waiting is part of the interstellar experience. Voyager's power supply continues to weaken as radioactive fuel decays. Instruments are shut down gradually to conserve energy. Each year, the spacecraft becomes simpler, quieter, more focused. This simplicity suits interstellar space. There is no need for cameras, no planets to image. What matters now are particles, fields, and long-term trends. The spacecraft has become a sensor more than a visitor. As Voyager continues, it will eventually lose the ability to communicate. Its signal will fade below detectability. At that point, it will become a silent object drifting through the galaxy. Even then, it will still be interstellar. It will still move between stars. It will still carry its golden record, its message, and the physical evidence of a civilization that once reached outward. Interstellar then does not mean gone. It does not mean finished. It means no longer defined by one star. This distinction is crucial for understanding the true scale of the solar system. If interstellar space begins only after travelling a distance many times greater than the planetary system, then the solar system itself is far larger than the diagrams suggest. The planets occupy the inner core. The heliosphere extends far beyond them. The heliosheath adds another enormous layer. And only after all of that does interstellar space begin. Even then, the sun's gravitational influence persists. So where does the solar system truly end? The answer depends on what you mean by end. If you mean where planets stop, that happened long ago. If you mean where the sun's plasma influence ends, that occurs at the heliopause. If you mean where gravity stops mattering, that lies far beyond anything Voyager will reach. Interstellar space is not the absence of the solar system. It is the context in which the solar system exists. Voyager's entry into this context has reshaped how we think about our cosmic neighbourhood. It has shown us that most of the space associated with our star is invisible, intangible, and easy to ignore, yet profoundly important. For listeners resting now, letting the ideas unfold without needing to hold them tightly, it may help to think of interstellar space not as a void, but as a quiet background presence, a medium through which stars move, a reservoir of material from which new stars and planets will one day form. Voyager is part of that background now. The spacecraft continues to drift, still sending data as long as it can, still measuring the galactic environment directly. Each bit of information adds to our understanding of what lies between stars. This understanding does not come in bursts. It arrives slowly. It accumulates. And that is perhaps the most honest reflection of what interstellar actually means. It is not a dramatic leap into the unknown. It is a gradual immersion into a larger environment, one that was always there, surrounding us, shaping us, even when we could not feel it. Interstellar is not an edge crossed. It is a condition entered. At a certain distance, the familiar tools we use to describe space begin to feel inadequate. Not because they are wrong, but because they stop helping us imagine what is actually happening. Voyager reached that point long ago, long before it crossed into interstellar space, long before the sun became just another star. The numbers used to track its journey started to lose their emotional meaning. Kilometers were the first to fail. In the early days of spaceflight, kilometers and miles still felt usable. Earth to the Moon, Earth to Mars, even Earth to Jupiter, while enormous, could still be framed as a very large version of something we understood. We could say hundreds of millions of kilometers and feel a sense of awe that was at least anchored to something familiar. But as Voyager continued outward, those numbers multiplied too quickly. Millions became billions, billions stacked on top of each other. The figures grew so large that they no longer produced a stronger sense of distance. They flattened into abstraction. Saying that Voyager is tens of billions of kilometers away does not feel 10 times more distant. than saying it is 1 billion kilometers away. To the human mind, both are simply very far. This is where measurement and understanding begin to diverge. Scientists anticipated this problem long before Voyager launched, which is why astronomy relies on alternative units designed to scale with space rather than with human experience. The astronomical unit, or anew, defined as the average distance between Earth and the Sun, became the first step away from everyday measurement. 1 astronomical unit feels reasonable, Earth to Sun, a distance we already accept as fundamental. When Voyager passed Jupiter at about 5 astronomical units, Saturn at roughly 10, Uranus near 20, and Neptune around 30, those numbers still carried some structure. They built on each other. They suggested a widening system, but even astronomical units eventually began to fail. As Voyager moved beyond the planets, AU values climbed steadily: 50, 100, 150. Each increase represented enormous distance, yet the numbers themselves stopped evoking anything tangible. This is not a failure of math. It is a limitation of perception. Our brains evolved to handle distances relevant to survival. Walking, running, seeing across a field, even travelling across oceans required centuries of adaptation and technology. Space operates on scales that were never meant to feel intuitive. Voyager exposed that mismatch. To cope, astronomers introduced time-based units: light seconds, light minutes, light hours. These units translate distance into delay, something we experience directly. A light second is about the distance light travels in 1 second. Earth to Moon is roughly 1¼ light seconds. Earth to Sun is about 8 light minutes. Already this reframes space as time. By the time Voyager was deep into the outer solar system, its distance was measured in light hours. Signals sent from Earth took half a day or more to arrive. Replies took just as long to return. This delay is not theoretical. It shapes every interaction with the spacecraft. When engineers send a command to Voyager, they are speaking to the past. When they receive data, they are hearing an echo of a moment that no longer exists. There is no shared now. Light hours feel more meaningful than kilometers because they tie distance to waiting. They make separation experiential. Still, even light hours have limits. As Voyager moved farther into interstellar space, light days became relevant. Then light weeks, conceptually, though not yet in practice for Voyager itself. Beyond that, light years dominate the language of astronomy. A light year is not a time, it is a distance. The distance light travels in 1 year, nearly 10 trillion kilometers. That number is so large it is functionally meaningless on its own. So astronomers use light years not because they are intuitive, but because they are scalable. They allow comparison. They let us say that one star is 4 light years away, another is 100, another is thousands. Voyager brings this scaling problem into sharp focus because it occupies an awkward middle ground. It is far beyond anything humans have visited before, yet still incredibly close compared to the distances between stars. This creates a strange cognitive tension. Voyager feels impossibly far, yet it has not even begun a true interstellar journey in terms of stellar separation. It has crossed the sun's boundary, but it has barely dipped its toe into the galaxy's vast interior. At Voyager's current speed, reaching the nearest star would take tens of thousands of years, and that star, Proxima Centauri, is only about 4 light years away. Many stars in the Milky Way are hundreds or thousands of light years distant. This reveals something deeply unsettling about scale. The solar system, which already feels unimaginably large, is still tiny compared to the space between stars. Voyager helps us feel this by existing in between categories. It is not near. It is not meaningfully far in galactic terms. It simply continues. Another way scientists try to bridge this gap is through analogy, shrinking the solar system down to something familiar: a football field, a grain of sand, a city map. These analogies are helpful, but they have limits. If the Sun were the size of a grapefruit, Earth would be a tiny speck several meters away. Neptune would be hundreds of meters distant. The heliopause would lie kilometers away. And the nearest star would be thousands of kilometers from that grapefruit. At that scale, Voyager would still be traveling between neighborhoods, with nothing but empty land in between. Analogies reveal something numbers often hide. Space is not just big, it is empty. The emptiness is not absolute. There are particles, fields, radiation, but there is nothing to look at, nothing to orient by, no surfaces, no landmarks. Voyager crossed billions of kilometers where nothing happened that could be photographed. Nothing happened that would feel like progress to a human traveller. This is another sense in which numbers fail. Distance implies motion towards something. But most of Voyager's journey is motion through nothing in particular. The spacecraft does not move from one object to the next. It moves through regions defined by changing influence, not by location. This makes traditional distance measures feel unsatisfying. They tell you how far, but not what that means. What matters more in Voyager's story is not the absolute distance from the Sun, but how the environment changes with distance. Sunlight fades, solar particles weaken, galactic particles grow stronger, magnetic fields shift, power declines, communication delays lengthen. These changes give distance texture. Instead of asking, how far is Voyager, a more meaningful question becomes, what does space feel like where Voyager is now? And that question cannot be answered with kilometers. Voyager has shown us that distance in space is experienced as transition rather than separation. It is not about leaving one place and arriving at another. It is about moving through gradients. This is why defining the solar system's size is so difficult. If you define it by planets, you get one number. If you define it by the heliopause, you get a much larger one. If you define it by gravitational influence, the number grows again. Each definition is correct within its own context. Numbers fail when we expect them to deliver meaning on their own. Another subtle way distance manifests is through energy. Every system on board Voyager must account for the increasing cost of communication. Transmitting a signal across greater distance requires precise pointing and careful use of limited power. Voyager's transmitter sends a signal that spreads outward at the speed of light, thinning as it goes. By the time it reaches Earth, that signal is unimaginably faint. Detecting it requires antennas the size of buildings, coordinated across continents. Even then, the signal must be extracted from background noise. Distance here is not just how far something travels, it is how much it disperses along the way. This dispersion mirrors how influence fades with distance. The Sun's light, the Sun's wind, Voyager's signal, all weaken not because something blocks them, but because space allows them to spread. This spreading is gentle, relentless, and indifferent. Voyager also reveals distance through delay in decision-making. Engineers must anticipate problems far in advance. They cannot react quickly. They must trust that sequences sent today will make sense tomorrow, next week, next year. This changes the relationship between human intention and machine action. Near Earth, space missions feel interactive. Commands are sent, responses are received, adjustments are made. Far from Earth, that feedback loop stretches until it barely feels like a loop at all. Voyager operates with a kind of autonomy enforced by distance. This autonomy is not intelligence, it is inertia. The spacecraft continues doing what it was last told to do, long after the people who gave those instructions have gone home, retired, or passed away. Distance here becomes generational. Many of the engineers who designed Voyager are no longer alive. The spacecraft outlasts them. It carries their decisions forward into a future they never saw. Numbers cannot capture that. This is another way measuring distance fails. It does not account for human timescales. It does not reflect how far something travels relative to a lifetime. Voyager's journey spans generations. That alone places it outside intuitive measurement. As the spacecraft continues into interstellar space, new distance scales will become relevant, not in practical terms, but conceptually. Tens of thousands of years, millions of years, galactic orbits measured in hundreds of millions of years. At those scales, distance and time blur together completely. The solar system itself orbits the centre of the Milky Way once every 200 million years or so. Voyager will complete that orbit alongside the Sun, drifting quietly, long after Earth's continents have reshaped themselves. At that scale, the distinction between far and near dissolves. Voyager is not going somewhere specific, it is participating in a motion shared by everything bound to the galaxy. This perspective is uncomfortable because it removes destinations, it replaces goals with trajectories. Numbers like kilometres, astronomical units, and light years are excellent tools for calculation. They are necessary. But Voyager shows us that they are insufficient for understanding. Understanding requires context. The true scale of the solar system is not something you grasp by memorizing distances. It's something you feel by recognizing how long transitions take, how gradually influence fades, how little happens across enormous spans. Voyager's slow progress forces us to confront the difference between movement and arrival. Even now, decades after launch, the spacecraft is still leaving, still transitioning, still moving through layers of influence that refuse to compress into a single value. For listeners resting and letting these ideas drift, there is a quiet relief in this realization. You do not need to hold the numbers. You do not need to remember distances. It is enough to know that the solar system is not small, that its true size lies mostly beyond the planets, that the space between stars is vaster still. Voyager teaches this not by declaration, but by example. By existing so far away that our usual measurements lose their grip, the spacecraft invites us to accept that some scales cannot be made comfortable. Distance at this level is not something to count, it is something to respect. And as Voyager continues onward, still measurable, still trackable, but increasingly removed from anything familiar, it carries with it a final lesson about distance. That when numbers fail, patience remains. The solar system's true scale is revealed not in units, but in years without arrival, in signals delayed by days, in transitions that take lifetimes to cross. Picture this not as a thought experiment meant to impress, but as a practical way to steady the mind when numbers stop helping. Shrink Earth down until it is no larger than a single grain of sand resting on your fingertip. Not a poetic grain, not a symbolic one, just an ordinary dry grain you might brush off a table without noticing. Now stop there for a moment, because this is where scale usually slips away. That grain of sand represents everything familiar, every ocean, every city, every memory, every moment of human history. All of it compressed into something so small that a breath could move it. This is not meant to diminish Earth, but to anchor it, to give it a size the mind can actually hold. Once that scale is set, everything else has to follow the same rules. If Earth is a grain of sand, the Moon is not right next to it. It sits several centimetres away. Already, this surprises most people. We tend to imagine the Moon as close, almost attached. On this scale, there is empty space you could easily see between them. The Sun, on this same scale, is no longer nearby either. It becomes a sphere roughly the size of a large beach ball, placed about 15 metres away from that grain of sand, not across the room, not just outside the door, far enough that you would have to walk to reach it. That distance, 15 metres, is the Earth-Sun distance, one astronomical unit. And even at this reduced scale, it is already larger than intuition expects. Now let's keep going, because this is where Voyager's journey really begins to matter. Mars, still small, sits several metres beyond Earth. The inner planets occupy a region you could walk across in seconds. Even here, they feel more spread out than the diagrams suggest. Then comes the long, quiet stretch toward Jupiter. On this scale, Jupiter is not just farther out. It is far enough away that Earth's entire neighbourhood feels compact by comparison. Jupiter becomes another small object, larger than Earth's grain but still modest in size, positioned nearly 80 meters from the Sun. That is almost the length of a football field. Between the Sun and Jupiter, there is nothing, just empty space. This emptiness is not a gap you skip over, it is the majority of the journey. Saturn sits roughly twice that distance from the Sun. Uranus and Neptune push the scale outward even further, hundreds of meters from where that grain of sand began. By the time you reach Neptune, you're standing several hundred meters away from your starting point, with nothing but open space behind you. And this is where most diagrams stop. On paper, Neptune often appears near the edge of the solar system, as if it marks some kind of boundary. On the grain of sand scale, Neptune is simply another small marker along a path that keeps going. Far beyond Neptune, the planets are finished, but the solar system is not. The Kuiper Belt, a region of icy objects, stretches farther still.
On this scale, it occupies distances measured in kilometers. Not steps, not fields, kilometers. Even then, the Sun's influence continues. Now place the heliopause, the region where the Sun's solar wind finally gives way to the interstellar medium. On this scale, it is not just beyond the planets, it is several kilometers away from the beach ball Sun. Let that settle. If Earth were a grain of sand, the true boundary of the Sun's influence would be so far away that you would need to travel by car to reach it. Voyager crossed that distance, not quickly, not dramatically, it took decades. This analogy does not exaggerate anything. If anything, it simplifies. It gives you something solid to hold on to when astronomical units and light hours stop meaning anything emotionally. The real lesson here is not how far Voyager went, but how much space there is between everything. Most of the solar system's volume is not occupied by planets. It is not occupied by objects at all. It is occupied by space shaped gently by the Sun's influence. Voyager spent years crossing regions where nothing visually changed, because on this scale, nothing is supposed to. When Voyager left Earth, it did not leap from one landmark to the next. It entered an environment defined by absence, long stretches where the only meaningful change was distance itself. On the grain of sand scale, Voyager's entire planetary tour occupies a surprisingly small region. The inner solar system fits within a few dozen meters.
The giant planets stretch it to a few hundred. Everything that revealed the true scale came afterward. From Neptune to the termination shock, from the termination shock through the heliosheath, and finally to the heliopause, Voyager crossed distances that dwarf the planetary system. This is where the illusion of closeness collapses completely. When people hear that Voyager has left the solar system, they often imagine it slipping just beyond the last planet as if stepping over a line. The grain of sand scale shows how misleading that image is. Voyager did not step out of the solar system. It walked steadily for kilometers, and even now it has only just begun to experience interstellar space. On this scale, the nearest star is unimaginably far away. If the Sun is a beach ball, the closest neighbouring star would be another beach ball located thousands of kilometres away. Not across the city, not across the country, far beyond anything you would casually reference. Voyager is nowhere near that next star. This is important because it reframes what interstellar actually implies. Voyager is between stars, yes, but between does not mean halfway. It means entering a space that is mostly nothing for a very long time. The grain of sand analogy also helps explain why Voyager's signal is so faint. Radio waves spread outward, thinning as they go, just like sunlight. By the time Voyager's signal reaches Earth, it has spread across an area so vast that only a tiny fraction is intercepted by our antennas. On this scale, Earth's receiving dishes are smaller than dust. Listening to Voyager is an act of precision and patience. Another thing this analogy reveals is why travel between stars is not a matter of building slightly faster rockets. Even if Voyager were 10 times faster, or 100 times faster, the scale would barely change in a way that feels meaningful. Space is not just big, it is overwhelmingly sparse. Voyager's success was never about speed, it was about endurance. If Earth were a grain of sand, Voyager would be a microscopic tag riding that grain outward, still attached to it by the faintest thread of radio light. That thread stretches across kilometers of empty space, and it still holds. This perspective also changes how we think about home. When Earth is reduced to a grain of sand, it does not feel less important. It feels more fragile, more specific, more precious. Voyager carried that grain story with it, etched into the golden record. Sounds, images, greetings, all originating from that tiny point. The vastness around it does not erase that story, it gives it context. As Voyager continues drifting deeper into interstellar space, the distances ahead become almost impossible to place on this scale at all. Tens of thousands of years of travel, millions, entire geological epochs passing as the spacecraft moves slowly through the galaxy. At that point, even the grain of sand analogy begins to strain. But it has already done its job. It has shown that the solar system is not a neat cluster of nearby worlds. It is a vast region where one star's influence slowly fades into the background of many others. It has shown that Voyager did not simply leave home. It carried home outward, across distances that cannot be rushed or simplified. And it has shown that when Earth is small enough to fit on your fingertip, the journey Voyager made becomes less about reaching somewhere else, and more about revealing just how much space there is between everything. Maps are comforting because they compress reality into something manageable. They take something too large to grasp and fold it into a page, a screen, a diagram that fits inside the boundaries of human attention. For centuries, our mental map of the solar system has worked exactly like that. A central sun, a sequence of planets, a tidy layout that can be memorized, drawn, and taught to children without overwhelming them. Voyager did not tear up that map. It quietly revealed that most of it was blank. Before Voyager, the solar system was often imagined as a planetary system with a little extra space around it. The outer planets felt like distant outposts, and beyond them lay a vague region of darkness that did not demand much thought. The focus was on the objects. The spaces between them were treated as background. Voyager forced us to redraw the proportions. When the spacecraft crossed the orbit of Neptune, it did not reach the end of anything. It entered a region that would take decades to traverse. That fact alone stretches the mental map. If the last planet sits only a small fraction of the way toward the Sun's boundary, then the planetary system occupies only the inner core of something much larger. This realization shifts emphasis from objects to influence. The old mental map centered on where planets orbit. The new one centers on how far the Sun's reach extends. That reach is not marked by solid bodies, but by particles, magnetic fields, and pressure balances that cannot be seen with the naked eye. Voyager changed our map because it traveled into those invisible regions and measured them directly. Before its journey, the heliosphere existed mostly as theory. Scientists understood that the solar wind must carve out a bubble in interstellar space, but the size and shape of that bubble were uncertain. Models varied, estimates differed. The termination shock, heliosheath, and heliopause were concepts supported by indirect evidence. Voyager transformed those concepts into measured realities. When the spacecraft crossed the termination shock, it confirmed that the solar wind does indeed slow down and heat up at a vast distance from the Sun. When it moved through the heliosheath, it revealed turbulence and complexity that simplified diagrams had missed. And when it crossed the heliopause, it provided the first direct sampling of interstellar space. Each of these steps added depth to our map. Instead of a simple circle around the planets, we now understand the solar system as a layered structure. Inner planetary region, outer planetary region, Kuiper belt, termination shock, heliosheath, heliopause. Beyond that, the interstellar medium. This layering dramatically increases the perceived size of our star's domain. Another way Voyager reshaped the mental map is through time. Before Voyager, the outer reaches of the solar system were thought of as distant but static. There was little sense of dynamic interaction beyond the planets. Voyager's data showed that the heliosphere expands and contracts with solar activity. Its boundaries shift. Its shape is influenced by the sun's motion through the galaxy. This adds motion to the map. The solar system is not a fixed structure drifting passively through space. It is an active participant in a larger galactic environment. Its boundaries respond to changing conditions. Its outer regions fluctuate over years and decades. Voyager's long-term measurements were crucial here. A single crossing would have offered a snapshot. Decades of data revealed patterns. The mental map also changed in terms of perspective. For most of human history, every measurement we made of space came from inside the heliosphere. Our instruments were sheltered by the sun's protective bubble. Voyager became the first outpost outside that shelter. That fact alone forces a conceptual shift. We now have two vantage points, inside and outside. The difference between them clarifies what the sun's influence truly does. It shields us from a portion of galactic radiation. It shapes local magnetic fields. It creates a distinct plasma environment. Without Voyager, these effects would remain abstract. The spacecraft also changed how we think about leaving the solar system. The phrase sounds decisive, as if it implies a clear boundary crossed once and for all. Voyager showed that leaving is gradual. First, you leave the inner planets, then the giant planets, then the planetary region altogether, then you cross the termination shock, then you move through the heliosheath, then you reach the heliopause. Each step redefines what inside means. This layered departure replaces a simple edge with a gradient. Our mental map had to accommodate that complexity. Voyager also influenced how we think about scale relative to the galaxy. Before its journey, it was easy to imagine the solar system as a reasonably large structure within the Milky Way, large enough to feel significant. Voyager's measurements revealed that even our star's full plasma domain is tiny compared to the distances between stars. This repositions the solar system within the galaxy's hierarchy. The Sun is not at the centre of anything beyond its own immediate region. It is one star among hundreds of billions. Its bubble of influence is impressive locally, but modest in galactic terms. That perspective humbles the map without diminishing it. Another important change involves communication. As Voyager moved farther away, signal delays increased dramatically. Commands and data exchanges stretched across nearly a full day. This altered how missions are managed. It introduced a new awareness of separation. Distance stopped being just a number and became an operational constraint. This operational reality feeds back into the mental map. It reinforces that Voyager is not just far, it is far enough that interaction is fundamentally different. The spacecraft's faint signal also highlights the scale of dispersion. Radio waves spread out, thinning as they travel. Detecting Voyager requires enormous antennas and precise calibration. This sensitivity to faint signals underscores how large the space between Earth and Voyager truly is. Our map now includes not just physical distances, but communication realities. Voyager also changed how we imagine the long-term future. The spacecraft will outlive the civilization that built it. Long after its power fades and its instruments go silent, it will continue drifting through interstellar space for millions, even billions of years. This longevity stretches the map forward in time. The solar system is not just a spatial structure. It is a temporal one. It evolves. Its boundaries shift. Its star moves through the galaxy. Voyager's journey is a thin line extending into that future. The golden record on board Voyager adds another dimension. It carries a message from a small planet orbiting a modest star. Knowing how far Voyager has travelled makes that message feel different. It is not just travelling outward. It is embedded in a scale that dwarfs it. This contrast reshapes how we see ourselves within the map. Another subtle shift involves the definition of center. In old diagrams, the sun sits at the center, surrounded by planets. Voyager's journey reminds us that the solar system itself is not at the center of anything larger. It orbits the center of the Milky Way along with countless other stars. This places our mental map within a broader one. The solar system is a local feature within a galactic disk tens of thousands of light years across. The heliosphere is a small bubble within that disk. Voyager is now sampling the medium that fills most of that disk. The map keeps expanding. Voyager's success also influences how future missions are conceived. Knowing that it is possible to reach and measure the heliopause encourages thinking beyond planetary exploration. It expands ambition. The boundary between solar system science and galactic science has blurred. Data from Voyager informs models of other stars' astrospheres. It helps scientists understand how different stars carve out their own bubbles in interstellar space. It connects our local measurements to universal processes. This interconnectedness further alters the map. The solar system becomes a case study within a broader galactic pattern. For listeners allowing this narrative to unfold calmly, the key point is not that Voyager made the solar system larger. It made it deeper. The old map showed objects. The new one shows influence. The old map suggested boundaries. The new one reveals gradients. The old map implied a tidy structure. The new one embraces complexity. Voyager did not discover new planets in its later years. It did something quieter and arguably more transformative. It filled in the blank space beyond the planets. Blank space, it turns out, is not blank. It contains structure, motion, and interaction. It contains the sun's fading influence and the galaxy's growing presence. It contains layers that cannot be seen but can be measured. By crossing those layers, Voyager gave us a more accurate sense of proportion. The solar system is vast compared to human experience. It is small compared to the galaxy. It is dynamic rather than static. It fades rather than ends. That revised map will remain even after Voyager's signal fades. Future probes may travel farther and faster. They may send richer data. But Voyager will always represent the first time we stepped outside our star's immediate influence and looked back conceptually at what we'd just left. That act of stepping outside changed the shape of the map in our minds. And as Voyager continues drifting deeper into interstellar space, still moving steadily, still bound to the sun by gravity even as it samples the galaxy directly, it carries with it the quiet proof that the true scale of the solar system is not defined by where the planets stop, but by how far a single star's influence stretches before it finally blends into the vast patient structure of the Milky Way itself. Long after the famous photograph was taken, long after its initial impact settled into textbooks and quiet reflection, Voyager's continued journey gave that image a deeper context than anyone could have anticipated at the time. The pale blue dot was never just about what Earth looked like from far away. It was about what distance does to meaning, and Voyager has spent decades extending that distance far beyond what the photograph alone could convey. When the image was captured, Earth appeared as a tiny point of light suspended in a beam of sunlight. It was humbling, emotional, and unsettling in a way that words struggled to match. Everything we know, everything we care about, reduced to a speck. That moment asked us to reconsider importance, scale, and perspective. But at the time, Voyager was still relatively close at least, compared to where it would eventually go. As the spacecraft continued outward, crossing regions that no photograph could represent, the pale blue dot transformed from a snapshot into a reference point. Not a place you could see anymore, but a concept you had to carry forward mentally. Earth did not grow smaller in Voyager's cameras. The cameras were turned off. What changed instead was our understanding of how far that dot truly was from everything else. In the early years after the photograph, it was still possible to imagine Earth as a distant object within a recognizable structure. The planets were nearby, the sun was dominant, the solar system felt like a defined neighborhood. Voyager quietly dismantled that comfort. By the time the spacecraft crossed the orbit of Neptune, Earth was no longer just far. It was lost among distances that defied intuition, and yet it remained the origin of every signal Voyager ever sent. This is the quiet tension at the heart of the pale blue dot revisited. Earth becomes less visible, less central, less influential in physical terms, even as it remains the only reason the mission exists at all. Every bit of data Voyager transmits is still aimed back toward that dot. As Voyager moved through the termination shock, the heliosheath, and eventually the heliopause, Earth transitioned from being a place within the same environment to being a place in a different one entirely. The spacecraft crossed boundaries that Earth itself has never experienced directly. From Voyager's position, Earth exists behind layers of solar influence, buffered by fields and particles that no longer surround the spacecraft. Earth is not just distant, it is sheltered. That distinction matters. The pale blue dot was photographed from inside the Sun's domain. Voyager now exists largely outside it. The photograph shows Earth isolated in darkness, but Voyager's later journey reveals that Earth is also enclosed within a protective bubble that shields it from much of the galaxy's harsher environment. Revisiting the pale blue dot with this knowledge changes its meaning. The dot is not just small, it is protected. It exists inside a rare pocket where conditions allow life to persist. That pocket is not guaranteed. It is temporary on cosmic timescales. The heliosphere itself changes as the Sun moves through the galaxy, expanding and contracting in response to interstellar conditions. Earth's safety is not permanent, it is contingent. Voyager's data underscores this without ever stating it outright. As the spacecraft entered regions dominated by interstellar particles, it measured increases in cosmic radiation that Earth rarely experiences at the same intensity. These particles pass through living tissue. They alter chemistry. They break DNA. On Earth, much of this radiation is deflected or absorbed before it reaches the surface. From Voyager's perspective, that protection fades quickly with distance. The pale blue dot, then, is not just a symbol of smallness, it is a symbol of shelter. That shelter was invisible in the photograph. Voyager's later journey made it tangible. Another layer emerges when considering time. When the photograph was taken, the signal carrying that image took hours to reach Earth. That delay felt manageable, almost negligible. Today, Voyager's signals take close to a full day to arrive. The pale blue dot is now not only far away in space, but far away in time. What Voyager sees and what Earth hears are separated by nearly a full rotation of the planet. This temporal separation changes how we think about connection. The photograph captured Earth as it was in a single moment. Voyager's ongoing journey captures Earth as a place that is always already in the past relative to where the spacecraft is. There is no shared present anymore. This does not weaken the significance of the pale blue dot. It deepens it. The image becomes not just a reminder of fragility, but a marker of origin, a timestamp embedded in space. Everything Voyager measures now is measured relative to something that no longer surrounds it. That fact alone reframes the photograph. At the time the image was taken, Earth was still part of Voyager's environment. The Sun's wind still enveloped both. The same magnetic bubble still contained them. Now, Earth and Voyager occupy fundamentally different environments. Earth remains inside the heliosphere. Voyager is largely outside it. The pale blue dot is no longer just far. It is on the other side of a boundary that defines what it means to belong to the solar system, and yet gravity still binds them. This is another subtle revision to the photograph's meaning. Earth and Voyager are still part of the same gravitational system. They orbit the centre of the Milky Way together. They share a long-term fate on galactic timescales. Separation, in space, is rarely absolute. Voyager's journey shows that you can be environmentally separated while still being dynamically connected. That nuance is easy to miss in a single image. The pale blue dot also gains new meaning when considered alongside the golden record Voyager carries. That record contains sounds and images from Earth, chosen to represent life on that tiny point. When the photograph was taken, the record was already aboard, but its significance has grown as Voyager has moved farther away. The farther Voyager travels, the more isolated that record becomes. It is no longer a curiosity attached to a spacecraft exploring nearby space. It is an artifact drifting through interstellar space, carrying evidence of a civilization that existed inside a small, protected bubble. The pale blue dot and the golden record are inseparable in this sense. One shows where the message came from. The other carries the message forward. Revisiting the pale blue dot with Voyager's full journey in mind shifts the focus from sentiment to structure. The photograph is often interpreted as a moral lesson. Be kind, be humble, recognize our smallness. Voyager adds a physical lesson to that moral one. Understand where you are. Understand what protects you. Understand how rare your conditions might be. Earth is not just small, it is specific. The pale blue dot exists at a precise distance from a star of a certain type, inside a bubble of charged particles of a particular size, within a region of the galaxy that happens to be relatively calm at this moment in time. Voyager's measurements show that small changes in these conditions could make a profound difference. This does not make Earth fragile in a sentimental sense. It makes Earth contextual. The pale blue dot is meaningful because of everything around it, not in spite of it. Another aspect of revisiting the photograph involves permanence. When the image was taken, Earth looked timeless, a dot against darkness, no hint of change. Voyager's continued journey reminds us that nothing about Earth's situation is static. The sun evolves, the heliosphere shifts, the galaxy moves. Over millions of years, Earth's environment will change. The pale blue dot will not always look the same, even if viewed from the same distance. Voyager's long-term perspective introduces that temporal dimension. The photograph captures Earth as it was. Voyager's journey hints at what it will become, indirectly, by showing how dynamic the surrounding space actually is. This makes the pale blue dot less of a frozen symbol and more of a moment in a long process. From the spacecraft's current position, Earth is unobservable. It cannot be distinguished from other stars. It cannot be photographed. It exists only as a remembered point. That fact alone would have been unimaginable before Voyager. Revisiting the pale blue dot now means accepting that Earth does not remain visible, even in principle, once you move far enough away. Visibility is a local privilege. This realization has consequences for how we think about exploration. If Earth disappears so completely with distance, then exploration is not about keeping Earth in view. It is about carrying Earth conceptually. Voyager carries Earth in its data protocols, its engineering decisions, its design constraints, and its record. The spacecraft does not need to see Earth to represent it. This is an important distinction. The pale blue dot photograph shows Earth as an object. Voyager's continued journey shows Earth as an origin. That shift is subtle but profound. Another layer emerges when we consider how the photograph is often used rhetorically. It is cited as evidence of insignificance, a reminder that we are tiny and therefore unimportant. Voyager complicates that message. If Earth were truly insignificant, there would be no Voyager, no spacecraft capable of leaving the sun's influence, no instruments measuring interstellar space directly, no signal travelling billions of kilometres back to a planet small enough to be invisible from where it is now. The pale blue dot is small, yes, but it is also capable. Revisiting the photograph in light of Voyager's journey reframes humility. It becomes not a dismissal of importance, but a recalibration of it. Importance is not measured by size or visibility. It is measured by consequence. Earth's consequence reaches interstellar space. The spacecraft's very existence is proof of that. As Voyager continues drifting outward, the pale blue dot becomes less of an image and more of an idea, a reference point that cannot be seen but must be remembered to make sense of the journey. The photograph asked us to look back. Voyager's later journey asks us to think forward. How long will Earth remain capable of producing something like Voyager? How long will the conditions that made it possible persist? How often do such conditions arise elsewhere? These questions are not answered by the image, but they are raised by its context. Revisiting the pale blue dot with decades of additional distance does not weaken its message, it sharpens it. The dot's small, the space around it is vast. The structures that protect it are large but temporary. The ability to reach beyond it is rare. Voyager's continued signal, arriving day after day from beyond the heliopause, reinforces all of this quietly. It does not lecture. It does not remind us explicitly. It simply exists, far away, still connected. As you rest and let this perspective settle, it may help to think of the pale blue dot not as a conclusion, but as a starting coordinate, a place defined not by what it looks like from afar, but by what it can send outward. Voyager has shown us that the true scale of the solar system is not something you see in a photograph. It is something you understand through absence, delay, and transition. Earth's image fades. Earth's influence persists. That is the deeper meaning revealed when the pale blue dot is revisited from a place so far away that the dot itself no longer exists as an image at all, only as the quiet, undeniable origin of a journey that continues, steadily, into a galaxy vast enough to make even memory feel like a kind of signal, travelling patiently outward through space and time. Out here, time stops behaving the way it does near home. It doesn't speed up or slow down in any physical sense, but it loses the cues that once made it feel anchored. No sunrises, no sunsets, no days marked by light or shadow. For Voyager, time is no longer something that passes in cycles. It is something that stretches. Near Earth, time is stitched into routine. Hours are defined by clocks, but also by meals, sleep, work, and conversation. Even in orbit, astronauts still circle a planet that turns beneath them, offering a rhythm that can be followed. Far from all of that, Voyager exists in a place where time is measured differently, not by repetition, but by delay. One of the first ways this becomes apparent is communication. When Voyager was close to Earth, commands could be sent and responses received within minutes. Problems could be corrected quickly. Adjustments could be made almost conversationally. That relationship faded gradually as distance increased. Now, a signal sent from Earth takes many hours to reach the spacecraft. A response takes just as long to return. What feels like a simple exchange becomes a process that spans most of a day. This delay reshapes the meaning of now. When engineers speak to Voyager, they are addressing a past version of the spacecraft. When Voyager replies, it describes conditions that no longer exist. There is no shared present, only overlapping histories. This separation is not dramatic, it is procedural, but its implications are profound. Time at the edge of the solar system becomes layered. Earth exists in one moment, Voyager exists in another. The connection between them is a thin stream of radio waves carrying information forward and backward through space, always late. This lateness is not a flaw. It is the natural consequence of scale. Light itself takes time to travel. Nothing can outrun it. At these distances, even light becomes slow. For Voyager, this means that every interaction is an act of patience. Commands are bundled carefully. Instruments are scheduled well in advance. There is no improvisation, no urgency. The spacecraft simply does what it was told to do long ago, until it's told something new. This creates a strange relationship between human intention and machine action. Decisions made on Earth today will affect Voyager tomorrow, or the day after, or later still. By the time those decisions take effect, The context may have shifted slightly, conditions may have changed, but the plan proceeds anyway. Time here demands trust. Another way time behaves differently at the edge of the solar system is in how change is perceived. Near Earth, change is constant. Weather shifts. Technology evolves. News cycles turn over in hours. Our sense of time is tied to rapid variation. Far from the Sun, change is slow and subtle. Voyager moves through environments that evolve over years rather than moments. Particle densities shift gradually. Magnetic fields adjust over long periods. Trends matter more than events. A single data point means very little. Meaning emerges only through accumulation. This slow unfolding alters how progress feels. There are no milestones you can celebrate easily, no obvious markers of advancement. Voyager's journey is not punctuated by arrivals. It is defined by continuation. Years pass without anything that would feel like a headline, and yet something is always happening. The solar wind continues to weaken. Interstellar particles continue to increase. The spacecraft continues to drift deeper into a galactic environment shaped by forces far older than our star. Time, in this context, becomes geological rather than personal. Voyager's power source reinforces the shift. The radioisotope generators that keep the spacecraft alive decay predictably and slowly. Each year, a little less power is available. Instruments are turned off one by one, not because of failure, but because of necessity. This gradual decline is measured in years and decades. It is not sudden, it is not dramatic, it is steady. Time is written into the hardware. Unlike most machines we use on Earth, Voyager was never expected to be repaired, upgraded, or refreshed. Its lifespan was defined at launch by the physics of radioactive decay. Every function it performs now exists on borrowed time. That borrowed time is generous by human standards but finite. This creates a quiet countdown that does not tick audibly. There is no clock counting down seconds. There is only a slow narrowing of capability. Yet even as systems shut down, the spacecraft remains functional, simplified, focused, alive in a minimal sense. Time here is not about urgency. It is about endurance. Another subtle change involves human perception of relevance. When Voyager launched, it was part of the present. It appeared in news broadcasts. People followed its progress. It belonged to its era. Decades later, Voyager exists almost entirely outside of everyday awareness. Its journey continues but quietly. It does not compete with faster, flashier missions closer to home. And yet, its relevance has increased, not diminished. Time has given Voyager context. The spacecraft has outlasted political administrations, technological revolutions, and cultural shifts. It has remained on course while the world that built it has changed repeatedly. This longevity reframes success. Voyager was not designed to deliver quick results. It was designed to persist. Time rewards that design. At the edge of the solar system, time also becomes impersonal. Voyager does not age in the way living things do. It does not anticipate an end. It simply functions until it cannot. There is something quietly honest about that. The spacecraft does not mark anniversaries. It does not know how long it has been travelling. It does not measure time at all. Time is imposed from the outside by those who track its signal and interpret its data. For Voyager, there is only state, power level, instrument status, orientation, velocity. Time passes whether anyone is watching or not. Another way time changes involves memory. On Earth, memory is reinforced constantly. We revisit places, we see familiar faces, we recognize patterns. Voyager leaves everything behind permanently. It does not circle back. It does not revisit. Its memory of the solar system is carried only in data logs and design choices. Once Voyager passed a region, that region was gone forever. This one-way journey gives time a directional quality that feels absolute. There is no return path, no chance to compare past and present directly. The only record of where Voyager has been exists on Earth, in stored data and human interpretation. Time, for Voyager, is irreversible. This irreversibility mirrors the larger structure of space itself. Stars form and evolve, galaxies change shape, nothing returns to its original state. Voyager participates in that flow. The edge of the solar system is not just a spatial boundary, it is a temporal one. Crossing it marks a shift from human-centered time to cosmic time. Human time is measured in years and generations. Cosmic time is measured in millions and billions of years. Voyager now exists firmly in the latter domain. Consider this gently. Voyager will continue travelling long after Earth's continents have shifted, long after languages have changed, long after current technologies have been forgotten. If nothing interferes, it will orbit the centre of the Milky Way alongside the Sun for billions of years. That timescale dwarfs everything we usually care about. And yet, Voyager's journey remains meaningful precisely because it bridges these scales. It began as a human project, conceived within a specific historical moment. It now unfolds within a cosmic one. Time at the edge of the solar system stretches that bridge. Another aspect of time here involves causality. Near Earth, cause and effect feel immediate. Push a button, see a result. Speak a word, hear a reply. Far from Earth, causality is delayed. Actions ripple outward slowly. Effects arrive long after intentions. This delay forces humility. It reminds us that control diminishes with distance, influence spreads and thins. Voyager's operators must accept that they cannot micromanage the spacecraft. They must let go. That letting go is built into the experience of time at this distance. The spacecraft itself embodies patience. It does not rush. It does not hesitate. It moves at a constant speed relative to the Sun, carrying momentum imparted decades ago. Its present is defined by past actions. This is another way time behaves differently here. The present is largely predetermined. Voyager's trajectory cannot be meaningfully altered. Its destination is not chosen day by day. Time, in this sense, feels pre-written. For listeners allowing these ideas to settle slowly, there is something calming in this realization. Not everything needs constant intervention. Not every process needs to be optimized. Some journeys unfold best when allowed to continue. Voyager's experience at the edge of the solar system suggests that time, when stretched enough, becomes less about urgency and more about consistency. It rewards systems that are simple, resilient, and patient. The spacecraft's continued operation, decades after launch, is not a triumph of speed or power. It is a triumph of time management at a cosmic scale. Eventually Voyager's signal will fade. There will be a last transmission, a final confirmation that the spacecraft is still alive, and then silence. That silence will not mean the end of the journey. Voyager will continue moving. Time will continue passing. The only thing that will change is our ability to listen. This eventual silence adds another layer to time at the edge of the solar system. It reminds us that observation is temporary. Existence is not. Voyager does not need to be heard to continue. As you rest now, letting the story move at an unhurried pace, it may help to imagine time not as something rushing forward, but as something expanding outward, just like Voyager itself. Near Earth, time feels crowded. Schedules overlap. Moments compete. Far away, time opens up. It becomes wide and patient. Voyager exists within that wide time now. It carries the imprint of a moment when humans decided to send something beyond the planets, without knowing how long it would last or what it would reveal. Decades later, that decision is still unfolding. Time at the edge of the solar system is not about counting hours. It is about allowing processes to run their course. Voyager teaches this by example. It does not hurry toward the future. It drifts into it steadily, carrying the past with it, as it continues into a region where time is no longer marked by clocks or calendars, but by how slowly the environment changes, and how long a single, patient signal can continue to cross the vastness between a small planet and the space beyond its star. Eventually, without drama and without warning, the steady conversation will begin to thin, not all at once, and not in a way that can be pointed to on a calendar, but gradually, as one small capability after another fades. This is the quiet future Voyager has always carried within it, a future defined not by failure, but by depletion. From the moment Voyager left Earth, silence was built into the design. The spacecraft was never meant to shout forever. It was meant to speak for as long as physics allowed, and then stop. What makes this silence slow is not uncertainty. Engineers know exactly why it will happen. They can predict the cause years in advance. Voyager's power comes from radioactive decay, and radioactive decay does not negotiate. It follows its own timeline, indifferent to achievement or distance. Each year, the power available to Voyager decreases by a small but measurable amount. There is no sudden drop, no cliff, just a steady decline. With less power, fewer systems can remain active. With fewer systems, the spacecraft becomes simpler. This simplification has been happening for decades already. Cameras were among the first systems to be turned off. Once the planetary encounters ended, there was no reason to keep imaging equipment active. It consumed power, generated heat, and served no purpose in the dark reaches beyond the planets. Other instruments followed over the years, some that studied planetary magnetospheres, others that measured energetic particles no longer central to the mission. Each shutdown was deliberate, discussed, and accepted. Nothing was lost unexpectedly. Nothing failed suddenly. Voyager was never allowed to waste energy. What remains now are the instruments most essential to understanding the environment beyond the sun's influence. Plasma detectors, particle sensors, magnetic field instruments, systems that can operate quietly and continuously, extracting meaning from an environment where change is subtle. Even these will not last forever. As power continues to fade, choices will become narrower. At some point, there will not be enough energy to keep heaters running for certain components. Temperatures will drop below operational limits. Instruments will fall silent not because they are broken, but because the environment has become too cold for them to function. This is a different kind of ending than we are used to. On Earth, machines tend to fail abruptly. A component breaks, a system crashes. Something stops working from one moment to the next. Voyager's silence will not arrive that way. Instead, it will recede. There will be a final year when one instrument is turned off, then another, then another. Each year, the spacecraft will know less about its surroundings, not because the surroundings have changed, but because Voyager no longer has the energy to listen. The signal itself will grow weaker too, not because the transmitter loses strength suddenly, but because maintaining that signal requires energy for pointing, stabilization, and amplification. Eventually, even transmitting a basic carrier signal will demand more power than Voyager can provide. At that point, Earth will still be listening. The antennas will still be pointed toward the region of sky where Voyager should be. Engineers will still schedule listening windows, software will still search for patterns in the noise, and then one day, nothing recognizable will come back. No error message, no final word, just absence. This absence will not be immediately obvious. There will be doubt. Was it a temporary glitch, a misalignment, a missed window? The listening will continue, cautiously, patiently. Only after repeated silence will the conclusion settle in. Voyager has gone quiet. It is important to understand what that silence means and what it does not. It does not mean Voyager has stopped moving. It does not mean it has broken apart. It does not mean it has reached an end. It means only that the last thread connecting it to Earth has finally grown too thin to hold. The spacecraft will continue on the same trajectory at the same speed, carrying the same mass, the same record, the same structure. It will continue to orbit the center of the Milky Way alongside the Sun, completing a galactic orbit every few 100 million years. It will simply do so without speaking. This is why the silence ahead is slow. It does not mark a dramatic conclusion. It marks a shift in relationship. Up until that moment, Voyager exists as both an object and a conversation. Afterward, it exists only as an object. For human observers, that feels like loss. For the universe, nothing changes. There is something deeply honest about that asymmetry. Voyager's silence will not be the result of neglect. It will be the result of endurance. The spacecraft will have used its power exactly as intended, for far longer than originally required. When Voyager launched, no one expected it to operate for decades. The primary mission was planetary exploration. Everything beyond that was a bonus. That bonus turned into a lifetime. This extended life came with responsibility. Engineers became caretakers of the machine that would outlast their careers, and in many cases, their lives. Decisions made early on affected how long Voyager could keep going. Every power-saving choice extended the future slightly. Every unnecessary action would have shortened it. The slow silence ahead is therefore also a record of restraint. As Voyager's voice fades, something else becomes clearer. The mission was never about continuous presence. It was about extending human reach as far as possible, for as long as possible, and then letting go. This is a difficult idea to accept in a culture that values constant output and immediate feedback. Voyager does not fit that pattern. It produces meaning over decades, then withdraws. The silence ahead also forces us to confront how we define success. If success requires constant communication, Voyager will eventually fail. If success is defined by how far influence extends, then Voyager has already succeeded beyond any reasonable expectation. The spacecraft has changed how we understand the solar system. It has reshaped our mental maps. It has provided the first direct measurements of interstellar space. None of that is undone when the signal stops. Silence does not erase impact. Another subtle aspect of this future silence is that it will arrive unevenly. Voyager 1 and Voyager 2 will not fall silent at the same time. Their power levels differ. Their instrument usage histories differ. Their environments differ slightly. One may continue speaking after the other has already gone quiet. For a time, one voice will remain while the other is gone. This staggered silence reinforces the idea that there is no single ending moment. There is only gradual quiet. The final instrument shutdown will not be announced to the public with urgency. It will likely be noted quietly in mission logs. Perhaps a press release will mention it briefly. Perhaps it will pass almost unnoticed. By then, Voyager's presence will be largely symbolic in public consciousness. Its scientific contributions will already be complete, and yet, the emotional weight of that silence will be significant for those who have followed the mission closely. There is something uniquely human about listening across vast distances, knowing the voice on the other end is faint, delayed, and irreplaceable. The end of that conversation carries a kind of gravity that is difficult to articulate. Not grief, exactly. More like acknowledgement. Acknowledgement that something built with care, patience, and foresight has done everything it can. The slow silence ahead also reframes how we think about exploration beyond Voyager. Future probes may travel farther, they may carry more advanced instruments, they may transmit data at higher rates, but they will face the same fundamental constraints. Energy fades, distance grows, communication weakens. Silence is not a failure of design, it is an inevitability of scale. Voyager makes this clear by living long enough for us to notice. In a sense, Voyager's silence will mark the moment when the mission becomes fully complete, not because it has ended, but because it no longer requires attention. The spacecraft will no longer ask anything of Earth. It will no longer need listening time, processing power, or decision-making. It will simply exist. This transition mirrors something larger about the solar system itself. The sun's influence fades gradually. The heliosphere thins. Interstellar space takes over. There is no sharp boundary, only a slow blending.
Voyager's voice follows the same pattern. Strong at first, then quieter, then gone. The symmetry is fitting. For listeners resting now, letting this future unfold without urgency, it may help to think of silence not as absence, but as completion. The mission was never meant to be eternal. It was meant to stretch human awareness outward until physics said no more. That point is approaching, slowly and predictably, and when it arrives, Voyager will not vanish. It will simply stop announcing itself. The spacecraft will continue drifting through interstellar space, carrying the golden record, its structural integrity largely intact, its trajectory stable for millions of years. If some distant intelligence were ever to encounter it, long after Earth has changed beyond recognition, Voyager would still be there, silent but intact. That possibility is not the purpose of the mission. It is a side effect, a quiet one. More importantly, Voyager's silence will not erase what it has already told us. We will still know that the solar system is vast, that its true scale lies far beyond the planets, that the sun's influence fades gradually into the galaxy. That distance stretches time and thins connection. Those lessons do not require ongoing transmission. They are already here. The slow silence ahead also invites reflection on how we listen. Listening across billions of kilometers requires patience, humility, and acceptance that not every signal lasts forever.
Voyager has asked us to practice that kind of listening for decades. When the listening finally ends, it will not feel like a door closing. It will feel like a sound finishing its echo. For a long time afterward, we will still know where Voyager is supposed to be. We will still be able to calculate its position. We will still include it in diagrams and discussions. But the relationship will have changed. We will no longer be in conversation. We will be in remembrance. That shift is not unique to Voyager. It happens to everything that outlasts direct interaction. What makes Voyager special is that it will outlast interaction by such an enormous margin. Long after the last signal fades, Voyager will continue to move through interstellar space, crossing distances that make its entire communicative lifetime feel brief by comparison. The silence ahead is therefore not the end of the journey. It is the end of our ability to witness it directly, and that distinction matters. As the spacecraft drifts onward, it will carry with it the final evidence of a decision made on a small planet around an ordinary star. A decision to build something that would go farther than anything before it, knowing full well that it would eventually go quiet. That quiet was always part of the plan.
Long after the last signal fades into background noise, long after Earth stops listening because there is nothing left to hear, Voyager will still be moving. Not fast in any dramatic sense, and not toward anything in particular, but steadily, patiently, carried by momentum that was imparted decades ago and will not be meaningfully interrupted for millions of years. This quiet continuation is where the true scale of the solar system finally reveals itself, not as a number, not as a boundary, but as an ongoing relationship between motion, time, and influence. When we talk about Voyager drifting forever, forever does not mean endless in the way everyday language suggests. It means unconcerned with human timelines. It means unaffected by calendars, civilizations, or the lifespan of technologies. Voyager will drift for as long as the structure that holds it together remains intact. And in the environment it now occupies, there is very little to disturb it. Interstellar space is sparse. Collisions are rare. There are no atmospheres to slow the spacecraft, no gravitational traps waiting to pull it into orbit around a planet. Voyager's path is stable, governed primarily by gravity on the largest scales. That gravity still comes from the sun. This is one of the most important points to hold gently because it complicates the idea of leaving in a useful way. Voyager has left the sun's plasma environment. It has left the heliosphere. It has entered interstellar space,
and yet it remains gravitationally bound to the Sun. The spacecraft and the Sun are still partners in a long journey around the centre of the Milky Way. Every 200 million years or so, give or take, the Sun completes one orbit around the galaxy. Voyager will complete that same orbit alongside it, slightly offset, tracing a parallel path through the galactic disk. This shared motion will continue for billions of years, unless something intervenes. That intervention is unlikely. The chance of Voyager passing close enough to another star to be significantly altered is extraordinarily small. Space between stars is vast. Even within the galaxy's crowded disk, stars are separated by light years of mostly empty space. Voyager will pass through regions of varying density, through interstellar clouds, and through magnetic environments shaped by distant stellar activity. But direct encounters are improbable. In this sense, Voyager's future is remarkably calm. It will not arrive anywhere. It will not be captured. It will not slow down in any meaningful way. It will simply continue. This is where the true scale of the solar system stops being about size and starts being about persistence. The solar system is not just a collection of objects arranged around a star. It is a moving system, embedded within a galaxy that itself is in motion. The Sun's influence extends outward not only in space, but in time, through the continued association of objects like Voyager that remain bound to it long after visible markers have been left behind. Voyager reveals this by refusing to end. Even when communication stops, the mission does not conclude in any physical sense. The spacecraft does not reach a finish line. There is no arrival state. It simply transitions from being observed to being unobserved. That transition forces a reconsideration of what scale actually means. When we say the solar system is large, we often imagine distance. How far the planets are from the Sun. How long light takes to cross those distances. Voyager adds another dimension: duration. The solar system's influence persists for extraordinarily long periods, even far beyond the regions we can easily define. Objects that originate within it continue to move with it, orbit with it, and participate in its long-term trajectory through the galaxy. Voyager is one of those objects. This means that the solar system's true scale cannot be captured by a snapshot. It must be understood as an ongoing process. The planets will continue orbiting for billions of years. The Sun will evolve, slowly growing brighter, eventually expanding into a red giant, shedding its outer layers and leaving behind a white dwarf. The heliosphere will change shape as the Sun's output changes. The surrounding interstellar environment will shift as the Sun moves through different regions of the Milky Way. Voyager will witness none of this in a conscious sense, but it will be present for much of it. That presence is what makes the phrase "drifting forever" meaningful. Forever here does not mean infinite. It means decoupled from human relevance. The spacecraft was built in a specific cultural moment. Its design reflects the technology, priorities, and assumptions of that era. And yet, its future extends so far beyond that moment that those origins become almost incidental. This contrast reveals something essential about scale. Human projects are usually judged by outcomes that arrive quickly. Success is measured in months or years. Voyager asks to be judged differently. Its significance grows with time rather than diminishing. The farther it goes, the more it reveals about the environment it travels through. The longer it lasts, the clearer it becomes that the solar system is not a compact structure with a neat ending. Instead, it is a long, tapering influence that blends gradually into the galaxy. Voyager's continued drift makes this blending impossible to ignore. When the spacecraft was near Earth, the solar system felt immediate. When it passed the planets, it felt large. When it crossed the heliopause, it felt vast. Now, as it continues through interstellar space without destination or deadline, it feels expansive in a way that defies closure. The solar system does not end, it dissolves. This dissolution is not weakness. It is a natural consequence of how stars interact with their environments. Every star carves out a region of influence. That region has a center where the star dominates and edges where that dominance fades. The Sun's region happens to be large enough that a spacecraft launched from a small planet can spend decades crossing it and still not reach anything resembling an abrupt boundary. That fact alone reshapes our understanding of where we are. Earth is not near the edge of anything. It is deep inside a structure that extends far beyond our everyday awareness. Voyager's journey makes that clear by refusing to conclude. Even the golden record aboard Voyager takes on a different meaning in this context. Often discussed as a message to potential extraterrestrial finders, it is more realistically a marker of origin. The record will travel with Voyager for millions of years, through environments that no longer resemble the solar system in any obvious way. Its existence says less about communication and more about continuity. This object came from somewhere. That somewhere was not just a planet. It was an entire star system with a reach that extended far beyond the visible. Voyager embodies that reach. As the spacecraft drifts onward, it will pass through different interstellar regions. The density of particles will change. The composition of the gas will vary. Magnetic fields will shift orientation. None of these changes will be dramatic. All of them will be slow. This slowness is part of the scale. At these distances, dramatic events are rare. Change is cumulative. Meaning emerges over long spans rather than in moments. Voyager's motion is best understood as a baseline, a steady reference against which the slow evolution of the galaxy can be considered. In that sense, Voyager becomes less a spacecraft and more a trace of where the Sun was, where it moved, and what it carried with it at a particular moment in cosmic history. This reframes the idea of exploration. Voyager is not exploring in the way a rover explores a planet. It is not sampling discrete locations, it is sampling continuity. By moving steadily through space that is mostly empty, it reveals how much of the universe consists of transitions rather than destinations. The true scale of the solar system emerges from this continuity. It is not just the distance from the Sun to the heliopause. It is the fact that objects originating within that distance continue to matter long after they leave it. Gravity binds Voyager to the Sun across interstellar space. That bond defines a scale far larger than any diagram. And yet, even gravity has limits. Over immense timescales, interactions with other stars, molecular clouds, or galactic tides could eventually alter Voyager's trajectory. The solar system itself may be reshaped by such encounters. Nothing is absolutely permanent, but these changes operate on timescales so long that they blur into the background of cosmic evolution. For now, and for a very long time to come, Voyager remains a quiet extension of the Sun's story. This realization changes how we think about true scale. True scale is not just how far something reaches. It is how long its influence persists. It is how gently it fades. It is how little effort is required to maintain motion once momentum is established. Voyager reveals that the solar system's true scale includes decades of travel beyond the planets, centuries of drift beyond the heliopause, and millions of years of motion through interstellar space, all while remaining dynamically connected to its origin. That's a scale no classroom diagram can convey. It must be felt through patience. As you rest now, letting this final stretch of the story unfold without needing to resolve into a conclusion, it may help to imagine scale not as a measurement, but as a kind of quiet confidence. The confidence that things can continue without supervision, that processes can unfold without intervention. That presence does not require constant signal. Voyager will not announce its continued existence. It will not update its status. It will not mark anniversaries. It will simply be there. This is the ultimate lesson of its journey. The true scale of the solar system is revealed not when Voyager crosses a boundary, but when it keeps going afterward.
Not when it sends its last signal, but when it continues without one. Not when we stop hearing it, but when it no longer needs to be heard to remain meaningful. The solar system, viewed this way, is not a finished structure. It is an ongoing interaction between a star, its remnants in the space they move through together. Voyager is part of that interaction now. It drifts through interstellar space carrying the imprint of a small planet, a modest star, in a brief moment when curiosity outweighed caution enough to send something beyond the known. That drift will continue long after the story of its launch fades from memory, long after the last antenna stops listening, long after the idea of a mission no longer applies. And in that continued motion, the true scale is finally clear. Not compact, not contained, not defined by planets, but extended, patient, and still unfolding as Voyager moves onward, not toward an ending, but deeper into a vastness where scale is measured not by how far something goes, but by how long it continues to belong to where it came from, even as it drifts through everything else.